I know I did. I hope you guys doing. So, first of all, welcome to Taiwan and thank you for coming to our conference. And then it has been a long 4 years since I saw you guys and met everybody. So, I mean, it's a long trip for a lot of people, and I hope you will have a good stay and good time during the conference and this evening.
Okay, the topic is about vibration, sound, and noise measurement with the VMS. VMS stands for Vibration Monitoring System. It's a very simple name, but it says exactly what it is. It's this red box here. So I will present the project that we were measuring. A practical application which is very rare for us because we are instrument manufacturer and we are selling our instruments, but in this special case we were using our instrument ourselves. Then it was leading then to a side comparison. I will talk a little bit about the calibration of the sound and noise, and then the further development we are planning to do as soon Ruslan is back from Sanlien, that we have again the engineering resources. So this was in Lausanne, EPFL, this is the Federal Institute of Technology, the French part, compared to the ETH in Zurich. There is a spin-off of Osram AMS, and they have two sites. One site, they have some research work going on, very sensitive for vibration, and they are considering to move to another site, which is on the right there, to move the lab there. So the question was, is the second place suitable due to vibration, sound, and noise? This was the task, and there does not exist any standards. It also did not exist any idea of them what is acceptable. They just know the first place there it works. So the question was then, second place, is it also acceptable? So the two components were needed. This was the VMS. The VMS is recording 3 channels of velocity, x, y, z. It calculates internally then the vector sum as the square root of the 3, and is providing every period which can be selectable. So in most applications, every minute, the peak of x, the peak of y, z, and the vector sum plus the related frequencies. Additionally, it is capable to record everything permanently. So with 1,000 samples per second, you can record all those channels. It has internally not just 3 channels to record, or then the 4th for the vector sum. It has internally 6 channels. And this is the advantage that we can connect also a sound level meter. This is the one here from BSWA, which we use now widely in Switzerland, and this BSWA 380 is a class 1 sound level meter. It comes with 2 outputs, and one output is the sound, which is based, you can select, but most time based on the dB on the A scale. So it is what the human being is recording, and you know then the values in dBA. So when people are going to the disco and so, or sound, what is acceptable for human being, this is in this dBA specified. Additionally, in this application, we were using the AC output. It's a little bit confusing because the DC output is the level in dBA, which is once per second, 2-3 times per second updated. This is just a level with no frequency information, nothing. But the AC output is a direct path through this noise, this sound level meter, which is related to the microphone, the pressure information. So you have from 10 to 20,000 hertz the pressure in a real-time signal. So this is much too high for the VMS because we are having We start internally with 4,000 samples per second, but we are recording this signal and we apply filters so that at the end it's treated like a vibration with 1,000 samples per second, usable 315 to 500 Hertz. So you see it on the bottom left. That is finally what we have. We are recording the noise as a function of the time with a frequency usable up to 315 Hertz. And again, this can be then treated that you have the peak and the frequencies of this noise. So now this noise, just to introduce this, is related to the structure-borne noise. When you know this Instantel equipment, they have their two microphones. One is this DBA microphone for sound, but they have this linear microphone also for this noise measurement. So now some recordings we were doing. Actually, you see on the vertical, on the horizontal, you see 2 weeks. Those are the days, and you see the weekends with low vibration. This is a diagram showing three channels and the vector sum, everything in one diagram with different colors. The red one is the vector sum, which at the end is the resulting of the vibration. So this is provided by the VMS. This is like the standard. This you can display in another form. You can display the whole information, all the 1 minute values in a diagram which has on the horizontal the frequency and in the vertical the value in millimeters per second. In this diagram you see in this side 2, that's the second side, that we are far below the Swiss standard for buildings, but this was also not the question, because you see this is the lowest scale of very sensitive buildings which is allowed, but we are here around factor 6 lower with all the vibration. Now I share with you something which I learned from my partner in Germany. When you have this, you say, okay, that's some information. You see a distribution of the values in terms of frequency and amplitude. But this is in the linear scale. He mentioned to me, put that in a logarithmic scale, and then it shows this way. So this is from 1 to 1,000 Hertz logarithmic display and also the vertical logarithmic display. And now you see some areas showing up which are related in that building. It's there in the second floor. You see that some building frequencies are coming out. So how the building is moving in X or Y direction. You see this can be evaluated further by civil engineers, but this information you get just simple by displaying the data in the logarithmic form. Now it comes to noise and sound. Sound is the dBA and the noise is the information in the low frequency range. Lower in the range of 65 dB. I'm looking here. This one is the sound and higher is the noise. First I was wondering why we have the noise higher than the sound, but this comes from exactly this dB, the A filter, which is lowering down, really filtering out the low frequencies because the human being is not sensitive for low frequencies. At the end, all was displayed in one graph. You see here the vibration, then the noise and the sound. And this allows now again to see the weekends here and here. And you see the relationship kind of synchronized. Of course, this again over 2 weeks. So this is done for both sides and is then ending up that you have 2 diagrams. I was making sure that you really have the same time frames for this measurement, the same scale. You have here for site 1 and site 2. This is the vibration, and as a human being, you see immediately, okay, on the second building, there is more in the vibration. Below, the same as above, but in the frequency range. And finally here, the different information about the building. Mainly this is related to the grounding. Here, this is a building standing on the ground directly, has no lower level floor. And in this building, you see the response of the building itself, as we were seeing in the picture before. Now, this is the comparison when you take all information, vibration, noise, and sound. We were already seeing that in the vibration it's more on this side, and impressive here is that actually both levels in sound and noise are much higher. So the question was then how we can quantify this, and there is nothing right or wrong, but how we were then explaining to the client. We were actually sorting the whole values. So these 1,440 values per day, these 14 times, then sorting and making sure that we have the same scale, so a linear distribution. And then actually you can display all values here in vibration from 1 to 100 or from 0 to 1. So a linear distribution. And then you see the differences here with the 2 sides. So dashed is, I guess, the side number 1, and the straight line is side number 2. The same information is here, but it's kind of better readable. You see here that the side 2 has higher noise because it's above this level, and for sound and noise, you see that, of course, the levels are higher in the second, but it's impressive that when it comes to the higher noise and higher sound, the other side is actually having higher values. So what the client is doing now with this is up to him. I did not hear anything anymore, but he was actually satisfied with this measurement. Now the calibration. By accident, I found this product from Norsonic for the calibration. BSWA has also calibrated, but only at 101 kilohertz. And this sound calibrator from Norsonic has the advantage that it has actually 2 frequencies to do the calibration. So on one side, you can do the calibration on 1 kilohertz. This is the normal calibration frequency for sound level meters when it comes to the sound in dBA. But for the noise calibration, it's very helpful to have now this 250 hertz. So this equipment you were using to calibrate the whole measurement. And this is then again a little bit special. When you do the sound, which you have this DC output, you can have the calibrator and you are recording in permanent, and then you calibrate the whole thing on this 94 dB. Now when you do the noise, you have an AC signal, and this AC signal I show here in blue. But then a physical effect takes care, which here you see very nicely. This is Nyquist criteria because we are filtering and we have a sampling which is far beyond. You are actually, you have to take some seconds of data to really find the peak of that what you are measuring. And this is then done with the absolute values here in another scale. And then you see here on the top, this is again the noise level then on 250 Hertz, and on the other side, the noise level on 250 Hertz with 114 dB. So this calibration is a little bit tricky but you have to understand this Nyquist effect, and you see it here nicely. But then it's really possible to do a precise calibration. So all this was then creating some more discussion within GSI plus with a client we are having, because they reported that more and more is also a demand to understand this structure-borne noise. This is a specialty of vibration measurement, and even now we are going to have a conference in Switzerland about this topic, because in this structure-borne noise, the standardization, how much is allowed and what are the levels and how you do, that's not yet frozen, that's not yet so stable. So that will come. We are contributing in this way. Having now a sensor, this sound level meter providing the noise as an AC signal, we can treat this AC signal as we were doing in that measurement. But now people are coming and saying, and in this domain, they are using the third octave bands which are standardized, these different frequencies. So they are interested to have those levels, and this online. So I was talking to Ruslan and was asking, is it possible that beside 3 accelerometers to treat and to do the processing on 3 accelerometers in parallel, is it possible to implement additionally up to 20 filters for every octave band in this VMS to process every octave band individually? So he says it's possible, but we did not yet implement. So we have to do that, and the goal is that you can define a certain fraction, the full band, or a certain fraction of thirds of the third octave bands, and then those are processed internally. After having this done, the bands, then you go into the normal processing of the noise, which is asking for this A weighting, because either you want it linear or you want it again weighted as for the human being. So this will be selectable, which essentially here, this is the A curve, and the linear curve is here straight. So you see the big differences in dB over this frequency range. After having this processed, it's done with different filter steps. You have to implement this fast filter. This is also a term which you use in the sound level meter. And having this, you can convert to dB or dBA, whatever is then the processing goal. So this is a project we are going ahead and we implement, and looks like towards mid of this year, this is going to be used by a client of ourselves. So the conclusions, we successfully measured both vibration and the complete information about sound and noise. Side comparison was possible, and for this side comparison, we introduced the technology of histogram. We are seeing an increasing demand of noise and sound and noise measurement. Actually, in my career now, this sound is used only for the last 4 years in Switzerland. Before, no demand, nothing. And it's now really appearing that this becomes more and more important, that is specified for construction sites, that this has to be monitored. With a specialty now that it goes just to the very end of this, you can almost say science, to have the structure-borne noise measurement. So this is then ultimately our goal, that we have in the VMS a flexible configuration for the sound and the noise measurement. So thank you very much for your attention.
I'll be going through why we want to do the sound level monitoring and some of the parameters we're looking for, and the devices we're going to collect those sound descriptors. And then we're going to talk about how the monitoring method has been progressed through the time, from the manual reading to the automated reading. And then I'm going to introduce some, show you some case histories. Okay, why we want the monitoring? As society improve, everybody's value their life and their health vary more and more. And when you have a lot of sound noise, it actually causes a health issue like hypertension, hearing loss, and stress, even going through mental problems. And from the construction point of view, it will cause accident because too noisy, it causes you lose of concentration and distraction, so you might have injured or even death. And finally, is quality of life. You know, I mean, you all know that living in a city, the noise level just get higher and higher. And some of the big city, you just constantly hear ambulance going past and the traffic horns and everything. So it's just reduce the quality of life. And more, the city, the local city like New York or maybe in Taiwan, Taipei, they start to impose restriction on noise, what kind of level you allowed, because people just, and also allow what kind of noise allowed when it's a working day and what's resting day, or in the evening, at night, they'll have different levels. So they're imposing that more and more. So making it monitoring more and more important. And when we do sound level monitoring, we are looking at a few parameters. And those parameters will describe the sound in numbers. So you can actually control it and monitoring it easier. And those are the four sound descriptors we're dealing with. The first one is sound pressure level. And I'll talk a bit more about it. The second one is LEQ, is equivalent sound level. And the third one is sound level percentiles. And the third is minima, maxima. So sound level pressure is actually the pressure produced by the sound. Basically, when the sound generates, it will create a vibration, it will create a wave, and create a pressure in air and get transmitted to people's ear. And it's measured in Pascal. Pascal is basically a pressure unit. And to make it standard, we actually calculate the SPL is 20 log, 10 base log over pressure times the pressure over reference pressure. So everybody in the world knows this is a number we can all prepare. So if you got an SPL in New York, SPL in Taiwan, they will be the same level. And typical sound pressure level, you can actually see it here. Leaf rustling, so basically, wind blow, the leaf rustle, there's only something like 10 dB. And in Pascal, it's very, very small. But as you go up, television set at home, you got 60 dB, you got 0.01 Pascal. And as you go even higher, a loud rock band, that's about 20 Pascal and 140 dB. So this gives you an idea, what kind of pressure what kind of sound level pressure we'll be dealing with through real life. And the equivalent sound level is a way to quantify the noise level to a single value over a time duration. Because the sound level go up and down, up and down. And when an ambulance go past, the noise go really high, and then between there's no noise. So people can withstand a sudden increase of noise, but if that noise continues over a long period of time, they'll get annoyed. So this is a way, averaging the effect out. But instead of using a linear averaging, is using a logarithmic averaging. And the idea is the sound level goes up and down, but during this time, you can do an equivalent, which is a straight line. And the idea is, under the straight line, the energy of the sound is the same as the energy under those waves. So that is the principle of LEQ. And the sound level percentile is another way people quantified the sound. And what it does is you say this is a sound wave going up and down, and 10% of those noise is above this level, and then we call it L10. So like a 10% of the 10% of the noise is, say this is 70 dBA. So L10 is equal to 70. And then we have like a T50, 50% of the noise is above this level, then we will say L50, say something like 50 dB. So that is one way you quantify the sound level. And some of the city, when they set out the regulation, the rules of controlling it, they will say, oh, the L10 cannot be exceeding so many dB, L90 cannot exceed so many dB. And then the way to do a sound, to collect those sound descriptor is using a sound level meter. That's a device, that's a hardware. And the most important things about the sound level meter is it responds to the same way as a human ear. So basically, we can't have a person there and listen to it and tell you it's too loud or not too loud. You basically make a sound level meter, to simulate a human's ear, and then give you a number. But the most important thing is it has to give you an objective and reproducible. So you use sound level meter, this sound level meter today, and use the sound level meter tomorrow, they should produce the same reading. And if you use the sound level meter produced by company A or company B, they should produce the same level. And what's the sound level meter composed of? First, it has to have a microphone, and which is usually on the tip here. And then we have a preamplifier that will amplify the very low signal from the microphone into a level that can be processed by the signal processor. And then we have a signal processor, which is basically the processing, like a computer processing the power, applies all sorts of calculation and filtering and everything. And the most important thing is it has to be done according to an international standard. So everybody produce a sound level meter that will produce the same result. And optionally, they can actually store the data and also do some variation calculation to it. And most of them will have a keypad and display unit. And most of them have a DC, AC output, and some of them has a serial output, and some of them have a USB output. As the times get passed, and the more and more features get put into it. And when the sound level meter doing a processing, the first thing it would do is do a frequency weighting, because the real world sound does not emit a wave at one frequency. And there is a combination of many, many waves at many, many different frequencies. And the human ear responds differently to the different frequency. So we have to apply a sound level filter to simulate the human's ear response. And typically it's being used, the two frequency weighting is A-weighted and C-weighted. And A-weighted is basically the most common frequency used. And what Christoph was talking about is dBA. The A represents A weighting. And C weighting is also used sometime, but they simulate the human's ear response to high level or impulse sound. But it's less frequently be used. But most of the sound level meter you can choose to use A weight or C weight. And time weighting is an interesting factor. And the reason for time weighting is initially developed because the sound level meter that's before the digital display is actually have a needle that go respond. But the thing is, the needle is using magnet and coil. They move very quickly, so you can hardly read it. So they actually apply a time delay on it so people can actually see it. And that gradually developed into a digital. But the thing is, digital, they have to simulate a needle moving as slower so people can actually read it. And the two most common speed is slow, which is time constant is 1 second, or fast is 1/8 of a second. And most of the time we use is slow. So basically, a sound level meter we're going to use in the normal noise control situation is slow and A-weighted. And how are we going to make sure sound level meter is repeatable and also reproducible? Is basically we can use by following the international standard. And the most common used standard is ICE 61672. And they actually have 3 parts. They talk about specification, how the sound level meter needs to comply, and also what kind of tests it can do, what kind of tests it recommends to make sure it complies to those standards. And most of the sound level meter available commercially usually has to go by some international standards. And those international standards are basically classified sound level meter in 2 classes, class 1 and class 2. And class 1 usually being seen as more accurate and is able to measure sound at a wider frequency range. It's precision grade meter due to the narrow tolerance level. And the most important thing is it's more expensive. It costs something like $2,000-3,000, at least, US dollar at least. And class 2 sound level meter is generally seen as less accurate. It's a general grade meter because it's wider tolerance level, has fewer features and functions, is significantly lower cost. You can buy a level 2 for a few $100s. And for most applications, the takeaway from this is, for most applications, class 2 sound level meter, it will meet the standard and is accurate enough and fit for the purpose. But most of the time, we buy sound level meter not because level 2, class 2 is good enough, it's because of specification. And when people write a specification, they always say, I want something more accurate. So they always end up having class 1, and really, no, in a lot of people's opinion, it's a waste of money. Okay, class 2, there's some example of class 2 sound level meter. Larsen Davis in the USA, Central 322 in Taiwan, and Larsen Davis class 2 costs about $1,000, and Center Technology, that costs about $300. And 𝗏𝗏𝗃 in Japan, that costs quite a bit too. And the list of features is typical features have an LCD display, simple data logging, simple integration, DC AC output, the range 350 to 1,500. And this is a very interesting development recently. In CDC in America, they have a NIOSH lab. They actually developed an iPhone app for noise monitoring. And all you have to do is get one of those phones with like what I call the iPhone interface. What I call is anyway, just push in the iPhone going upside down, push it on the bottom of it, and you run the app. And it can be up to meet class 2 requirement if the microphone is being calibrated properly. So this is quite an interesting development, and it basically do pretty much all the SLM can do. And it can do more because the processing power in the iPhone. And I often joke with my colleagues that the development of a smartphone is so widely available now. It contains tilt meter in there, it contains a accelerometer, it contains temperature sensor, it contains a display, and a very powerful processing power. In the future, instrumentation, we just go around putting iPhone everywhere instead of putting tilt meters. It also communication, basically everything built in. And it's getting cheaper and cheaper all the time, right? I think the problem is it's not rugged enough. Anyway, class 1 sound level meter example is Larsen Davis in USA, BSWA in China. That's what Christoph used, and B&K from the UK, and 𝗏𝗏𝗃 from Japan as well. And the list of features, usually they come with colored display, which it doesn't really have too much added value, but make it nicer. And some of them with touch screen as well, which is basically going towards the smartphone more and more. And they have data logging, and data logging can be very sophisticated. They can read A weighting and C weighting in the same time, and log them in the same time. They can have fast and slow, basically, a lot more power into it. And a real-time third octal frequency analysis, which is what Christoph has been talking about. And one of the things which is more and more people want is sound clip recording. And that's what Christoph's saying, recording from the AC output. And the reason for that is people, like in a city where you're doing noise monitoring, when you're doing construction work, you need to be monitoring the noise. But how are you going to tell this noise is created by you or created by next door, or somebody just or ambulance just drive past, or somebody is playing boombox nearby? So the only way to tell that is to record the sound. Whenever it exceeds the threshold, they record 15 seconds, 30 seconds, and you can play back. And also, building remote and mobile access, which is like we're showing here, sound level meter can actually interface with your smartphone. And because of all those features, the price start about $3,000. And it go up, even it can go up a lot more if you start having those sound clip recording and built-in remote access. Okay, now we're going to talk about sound level monitoring, how it was done in the old days. And the sound level monitoring in the old days is done by a handheld sound level meter. Basically, a guy would take a sound level meter, go to a location near where the sound is generated, and then we'll start monitoring and take 15 minutes reading, and then go to the next point, take 15 minutes reading, and then just go around places, and then go back, download the data if he has a data logging facility, and put into Excel and calculate it, and then generates a report. But what happened outside the 15 minutes? No, he wouldn't know, because it might be some ambulance go past or some other noise. He would not get it. So there's more and more people want to have continuous monitoring and real-time monitoring and unattended monitoring. And this is an example of what the specification wants. Basically, they set out they want to have sound level, a sound clip. And so remote monitoring, unattended monitoring, so you can just put it there and they will collect all the data and automatically send to a website. And also real-time alert to show you what's been happening. And every time is optionally, every time it triggers, every time it exceeds the threshold, it'll capture a sound level. And some people want to have optional third octal frequency analysis in real time. So this is devices now when we try to automate it, remote and unattended. So basically we put a handheld sound level meter interface with a data logger, collecting information from the DC port, record them, process them, and then there's a modem here. We just send the data to a remote website. And it consists of a Campbell data logger and one C322 from the center technology. And or sometimes we use Larson Davis, depending on what people want. And we have a battery with AC charger. And we have a program running in the data logger which will calculate all those sound descriptors. And data collected automatically and remotely and for display and alert based on a web-based visualization software, things like VDV or Argus. And this has been used since 2015. And some of our customers are still using it. But it's very bulky and take time to build it up. I can't go to the next one. Okay. So this is another version of the Ultra SLM. They actually have two sound level meter connected to a data logger. So they actually have one LTX1 and one A31 class 1. And they actually put at different levels. One is higher and then the other. And then this is the one that we actually created to have the sound level clipping functions to it. And this is basically using a computer, a PC. The problem of this is it won't work with battery. It has to have AC power. And this is the one that the latest development, latest product available, is basically a purpose-built integrated unit with Wi-Fi and outdoor application. Basically, everything is in one. As you see, is basically here, and we can run on solar panel. And it does sound clip and 1/3 opto and everything, and it's being used since 2019. So, talking about how it was applied, this is a job in New York when they were doing work near the Midtown Tunnel, and it creates a lot of disturbance because because they have all the traffic diversion, and everybody is getting frustrated. They're beeping their horn and everything, so they need to separate that from the construction noise. So this one, they use AutoSM-SC. And this is the latest case history. It's being used to monitoring a rock festival in Boston. And they have a lot of famous band, a very noisy rock band there. And in the community, everybody's worried about how noisy it can be. And what they have is they actually have the latest one, the integrated unit, scattered around the festival site. And because it has instant real-time display, they have a guy walking around with iPad, actually can see the sound. So they told us one time there was a police come and say, you got some complaint. And then they just show the police the iPad, and the reading was below the level. So the police goes away. So that's something which is actually ensure the quality of life, and also ensure that rock band can go on. Okay, thank you very much. Any question?
So we already know something about the EtherCAT. We can go into our product, 𝗏𝗏. 𝗏𝗏 is a 4-channel EtherCAT I/O slave module. And he almost implements all features of EtherCAT I just mentioned. Something like POD and DC, and it built-in 3 filters, inside. There are notch, low pass, high pass. And it's in application we think with EtherCAT advantage. You can use in something like bridge monitoring, because bridge is a linear structure. It's suitable for use daisy chain with POD. And algorithm like hazards, it needs to more synchronized time. You can use DC technology to survive this problem. And this year we will have 2 products to release. First is EF410. This is for FPA sensor. And the other is EB410 for strain. So we can see his look at the right. At the top, he is the front side of 𝗏𝗏. He has 3 connectors. At the left is Ethernet input. In the middle is Ethernet output. At the left, here has a power connector. If you use the POD technology, you don't need to use it. Below this picture is the back side of 𝗏𝗏. Here has a sensor connector. This is the spec of 𝗏𝗏. He has 4 I/O channel, and the ADC resolution is 24-bit, with sampling range 1,000. Sorry, and powering we support two kinds. First is if you use separate power, the range is 10 to 30 volt, and if you use BOD, it's 24 volt, and its instrument noise is greater than 130 dB, and time synchronized can be less than 100 microseconds. And waterproof is IP67. The communication speed can be 100 megabit per second, and transmission distance is 100 meters. So we recommend if you use our EF410, you can also select our Shrek FA335. This is a high sensitive triaxial force balance emitter. Of course, this sensor will do the full testing with our EF410. Now, here is our vision of the Dalton system. As you can see, we want to connect all the dynamic and static data, use Dalton to integrate, then send the data into the EtherCAT network, and use master to convert the EtherCAT with Ethernet. Then you have IPC with standards inside. You can very easier to integrate to your cloud. And the standard is data acquisition system developed by Sanlien. And we will, and this software can let you very easy to setting, monitoring and recording, also analyzing the data in very easy way. And we will have a topic to talk about it tomorrow. So if you have you interested in this software, please don't miss it. And here is some project we will use Dalton to build it. And first is SHM monitoring system of a hospital in Taiwan. The other is in Vietnam. This is a chain cable monitoring system. So if you are interested of how to use Dalton to build the monitoring system and any idea want to share, and I and my colleague will be the demonstration room to waiting for you. And that's all my presentation today. And thank you for listening. And I hope you have a nice day in Taiwan.
So, to start, I will going to show you the ERI, means earthquake recording instrument. We call it accelerogram and geotechnical projects in the Philippines. So prior to the registration of our company, we started promoting PLR Plus accelerogram in the Philippines. We were invited by the Department of Public Works and Highway, a government agency, to present the Sanlien technology invention of PLR Plus prior to the approval of the earthquake recording instrumentation, Section 105.2 of the National Structural Code of the Philippines and Section 102 of the National Building Code of the Philippines, otherwise known as the Presidential Decree 1096, the guidelines and implementing rules on earthquake recording instrumentation for buildings, which was approved in January 12, 2015. I will never forget that because that is my birthday. So, how AF drill techniques started? So, building better together, bringing innovation to the corporation that inspire and implement solution to our customers' need. We started in 2015, promoted the accelerogram earthquake recording instrumentation in 2015 also, expand our operation to drilling contracting services in 2018, and then acquired brand new drilling machines for geotechnical drilling and grouting projects application going forward. Our projects, since our establishment in 2015, we already installed more than 100 high-rise buildings, condominiums, hotel, BPOs, etc. Owned by the largest property developer and investor of mixed-use estates in the Philippines. More than 30 essential facilities, power plants, and lifeline structures such as hospital, top-notch school, and universities of the leading health and education institution and largest power developers in the Philippines. We install ERI system for several power plants, geothermal, wind, and solar hydro, and became the partner installer of the largest producer of geothermal energy in the Philippines. We call it the Energy Development Corporation. And the second largest in the world. We have worked with them to develop and integrate the PLR to their monitoring system using their local server. Actually, all their geothermal in the Philippines is being monitored in Manila. Okay. So we also have our trained and experienced structural engineer who are member of the Association of Structural Engineers of the Philippines as a technical support. My guy, Sir Boying, to our installation project, ensuring that our installation meet the requirements of the NSCP, the National Structural Code of the Philippines, and the DPWH issued IRR on ERI. Our team were able to deliver and complete several installation projects, even the time of pandemic, complying the Philippine government mandated safety protocols on COVID-19, including additional requirements by our respective clients. Even COVID time, we are working, actually. So more than 150 buildings and counting. So this is the University of Santo Tomas. The Filipino knows this school. So that is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the new one, which is their senior high, which equipped with 3 outside of that perimeter. So this is how we install our earthquake recording instrumentation. So one on the top, in the middle, and in the ground. But take note, it is on the discretion of the structural engineer how to put the instrument on the ground level. So this is the, as you can see, this one. This is how we install it. We protect it with a steel protection. This is the schematic diagram of how we install it. So this is the reason why I asked Jim if we still need these D-links. My system still needs the D-links. That's the reason why I asked question. So we supply it complete with the computer. So that is the conceptual view, as you can see on the screen. So geotechnical instrumentation. We're currently promoting the following in our territory: inclinometer system and the GeoFlex, rod extensometer system, piezometer system, and double water packer testing. So this is my current project. This is a cut and cover. This is the project of Acciona. If someone from Spain here, the contractor is Acciona, and we are the subcontractors. That perimeter, we installed inclinometer system, 27 units. Once they excavate this, they file it with a sheet file, and at the back of the sheet file, we put the inclinometer system. So they monitor the tilting of the sheet files. rad extensometer system. We installed this in our project in Caliraya Dam, which is owned by the National Power Corporation. This is we installed this vibrating wire piezometer at Philex Mining Corporation. So you see that the drilling machine, I have 4 of that, which costs about 20 million each drilling machine. So this is the procedure on how to get the water packer testing. If you are going to build a dam, you do the geotechnical investigation. You'll do the water packer testings and the hydrofracturing. This is one of those. Thank you very much.
So we are Sara. We are a small company based in central Italy. And we are operating since several years because we are a handicraft company. But from about the year 2000, we focused only on seismic equipment. We had the experience on electronic, but from 2000 we based it on seismic equipment. And until now we served more or less these numbers. So we have some hundreds of clients worldwide and manufacture over 5,000 seismic units, including accelerometer, digitizer, etc. And over these 5,000 units, there are about 750 seismic recorders and also 16,000 accelerometer transducers that also Sanlien use from us. We commissioned also geophones because we deliver geophones for geotechnical or geophysical exploration devices that I will show you later. And also several borehole units because we produce several borehole units for the oil and gas monitoring. Also we have, we can say, quite a large portfolio of software processing software suites, and we will show you a little later. We have clients mostly worldwide, especially in Latin America and of course Europe, Turkey, and Spain. So now what I'm focusing on this presentation is for the applied geophysics and microseismic monitoring solutions that we developed during the years. We have tools for soil exploration, and it's very important, and also the recent earthquake in Turkey demonstrated how much important it is to know how is the soil before reconstruction. So we have instrumentation that allow the geophysicists, the geologists, and the engineers to comply the building codes before the construction. The building codes comes from, usually used worldwide, comes from California. So in California, the building codes started several years ago. Tells that you have to determine the elastomechanical property of the soil of at least of the first 30 meters from the surface. So we provide the 𝗏𝗏𝗏, the geobox, and also downhole probes and processing softwares. What is the 𝗏𝗏𝗏? 𝗏𝗏𝗏 is a portable geophysical seismograph, multi-channel, and that have the peculiarity to have the digitizer near the geophone for the best data quality. Probably it is not the most robust system in the world because there are many other manufacturers of exploration seismographs which give very high performances, especially in the desert or in harsh environment. But this instrument has been very appreciated because digitized very near to the geophone. And the less is the length of the analog cable, the better is the signal you get out from the digitizer. And so also we have in this system a modularity because you can purchase one channel by one channel. You can compose like in a daisy chain, like the instrument presented for the bridge monitoring, which is the datum. You can connect in a chain, many units. So you can combine your seismograph according to what your needs and budget. And during the time, you will also have an opportunity to translate the managing software in Chinese. So if somebody in Taiwan wants to use it, it's easier. Yeah, and another tool that we developed for, not developed, but I mean, we produce and developed for this specific survey is the GeoBox. The GeoBox is a special tool for performing Nakamura method surveys, HVSR. HVSR, for who don't know what is this method, is a methodology which perform the frequency domain analysis of the three components seismograph using ambient noise, so using the noise which is always present in the ground, and divide the spectrum, combined spectrum of the two horizontal components by the spectrum of the vertical components. I don't know if it is possible to yeah, no, sorry, to zoom on the is this the laser? Is here? Okay. So it's not so visible here, but this yellow curve is the ratio between the horizontal over the vertical spectrum. And this put in emphasis, according to the Nakamura, Yutaki, I think it's Yutaki Nakamura, I think, is from Japan, which found that this is a very valuable indicator of the soil stiffness and soil capacity to produce amplification during earthquakes. So in this case, So in this case, in this frequency, about 4 Hertz, there is an higher capability for the soil to produce an amplification in case of earthquake. It's interesting that also this method can be used to estimate the bedrock depth in a very fast way. It is the frequency of the peak we find in the HV is related to this formula, to this equation, with this Vs is the velocity of the S wave of the one layer of soil, divided by 4 times the depth of the thickness of the layer. So you can determine the inverse formula using the Vs, if you know, and calculating from the frequency. So you can calculate the thickness of the layer, more or less knowing the velocity of the surface waves of the first layers. You can determine the depth of the bedrock. This is not an exact number because, of course, the property of the Vs, I mean the Vs value of the layers of the soil are not always well known, but with some clue, maybe the geologist knows more or less what type of the soil is, that they can infer how much more or less is the Vs, and then you can determine quite accurately the thickness of the first layer down to the bedrock. Also, we produce for these applications a downhole probe, which is used to determine the velocity of the soils using, of course, a borehole, a hole in the ground, and then you energize from the surface. And with a seismograph, that can be, for example, the 𝗏𝗏, you can measure the travel time from the shot to the receiver and determine in this way the velocity of the rocks or the soils that you have below the surface. For this instrumentation, we developed a complete suite of soil exploration software. So you can use these tools for refraction surveys, so to make a kind of tomography of the subsoil, or using just surface waves using MASW method, MASW. Maybe you know this, is quite common worldwide. And also we provided interesting tools to use reflected waves from surface. So if you energize from the surface, you generate elastic pulls that go down and be reflected by the impedance contrast of the soil when the waves go down and come back. You can determine several mechanical properties using these tools. For example, the most simple is the HVSR analysis. There is a specific tool for this. And so you can have your stratigraphy, inferring the stratigraphy. You can put your stratigraphy and see if the stratigraphy you put, it's a synthetic curve is generated. And when the synthetic curve matches the experimental curve, you have a good chance to have picked the correct stratigraphy. Of course, you have to be a geologist, have some experience on how the soil behave on this. We have the software to analyze the surface waves and also obtain a stratigraphy from analysis of the surface waves. Downhole analysis, of course, for the determine, of course, the VS30 or VS equivalent characteristics of the soil, like Poisson ratio, geophysical density, shear modulus, Young modulus, etc. We also, the suite is also composed by a tool to analyze in refraction. So you can reconstruct or imaging the subsoil in 2D. The others are all 1D. And this is an interesting tool which could be used to find water. It's a kind of quite innovating method, because in a simpler way, without knowing exactly the reflection methodology, you can, using just a small number of geophones in a single point. You can see the geophones here in the picture. So you shot with a small hammer, and the reflections that comes out give you an idea if the waves that are coming back to the surface has been reflected by some granular soil. If there is a granular soil in one, maybe 100 meters, 200 meters, whatever, they reflect with different frequency patterns. So the software put in evidence this frequency pattern, which is coming from granular soil, and the granular soil most probably can contain water. So you can determine the probability that in your soil there is water. Because if there is a granular soil, the probability which it contains water is high. If it is solid, almost not. And of course, we also make a more efficient and more complete software for reflection, 1D, which make the reflection methodology, which is quite complex and based on the oil search company, to determine the soil properties using, for example, P waves or S waves, depending on what you prefer or what you need. And the important thing that this method is that you can reach a proportion of depth and length. I mean, the depth of the investigation and the length of the seismic line is more or less 1:1. So if you want to go down 100 meters depth, you probably just need 100 meters seismic line. For the other technique, like refraction or like MASW, the ratio is much higher. I mean, for refraction, to get 100 meters depth, you have to go at least 300 meters long in a seismic line. For the reflection, it's the seismic length, it's less demanding. So it can be an opportunity. Okay, and this is what I presented for the geophysical investigation. And the other example is for the tools for seismic and microseismic monitoring. We have comprehensive sensors and recorders manufacturing for high-resolution sensor, high-resolution recorders, borehole, post-hole sensor, or hybrid sensor, and I'm going to show you. So this is our recorder, which is now available also in not only in the ruggedized box, but also in a more less expensive housing for indoor use when the rugged housing is not necessary, and also available recently introduced in a resolution higher than 24 bits. Not for very high sampling rates, but we can have 24, 26, or if you want, also 32 bits. It is compatible with all the seismic software, like 𝗖𝗯𝗵𝗶, very common in the Asian market, of course, because it supports seedling. And it is very, very efficient with geophones. It has an ultra-high resolution. It can detect, using simple geophones, displacement of few nanometers in the band of down to 0.2 hertz using geophones, not using broadband sensor. I mean using simple geophones, because it has really high quality for the low frequency signal. And also, thanks to it has been also approved by, thanks to 𝗔𝗀𝗃, it has been also approved for the 𝗘𝗥𝗜 authority, the SLO6 channel. Then in the same box, we also provide a solution for weak motion with the sensors inside. So it is named 𝗏𝗏box and the 𝗏𝗏box hybrid. The 𝗏𝗏box hybrid is a new sensor we introduced it this year, which it has not only geophones or seismometers inside, including digitizer, but also include a MEMS accelerometer, all synchronized. So you have both strong and weak motion in the same box. And this can allow you or allow monitoring network for earthquake to get weak and small earthquake signal recorded very well by the seismometers. And if the shake becomes higher, the MEMS sensor detects without clipping. So you don't lose any information of the earthquake. As I said before, we also produce a series of downhole and posthole sensors. This is one example of borehole carrier with a hole lock. So it has the possibility to lock inside the pipe at any highness. And this type of carrier can carry not only geophones or seismometers, but also accelerometers, FBA or whatever. Regarding seismometers, we also produce since some years a broadband sensor. The bigger one is the observatory grade, so it has a very low self-noise. And the other one in the corner is a compact one. It has been introduced this year, which has a little higher noise, self-noise, but it's much more compact, and it also can be embedded in a borehole sensor. In fact, this is one of the sensor made for the borehole. You have the electronic here, the digitizer over there, the element of the broadband sensor here, and accelerometer on this part. And this is the gimballing system to level this platform. So if you put the sensor in a borehole, the borehole could be a little bit bended because the drilling is not always perfect. So when it is maybe a 100 meter depth in the depth, the tilt have to be compensated. So we have a mechanism to compensate the tilt. This is one of the installation in North Italy. It has been installed this hybrid version because it has accelerometer and seismometer in the same capsule. These are another example of an SSO8 borehole deployment in Turkey for an oil and gas facility. And so after deployed all these sensors, you have to also process the data for earthquake location. So we have in a SeismoWind a comprehensive software suite for earthquake management. So we have a series of modules which can record the data stream coming from the seismometer. It's also compatible with, of course, it's compatible and follow SeaLink transmission standard. So it can get the data and retransmit the data, relay the data. You can calculate the transfer function of your seismometer and connect the transfer function to the processing module. It has modules to evaluate the noise floor of the site, because it's important when you deploy a seismic device that you know what is the seismic noise on the site. If it is properly, if the place can be properly used for seismic survey or not. You have to determine this. So we have these tools. You have the tools to determine the status of health of your network, and etc. For example, this is one of the software, which, for example, this is the recording software, which manage a number of channels. We have systems running 300 channels, 400 channels, currently running in Italy. This is the stream, all the streams of each line is one component of the seismograph. And this is the model which, I don't know if this is true. This is a model which can allow you to design how to deploy or where to deploy a seismic station. You can design your network, you can evaluate where the faults are, and also determine the status of health of the system. And we also have, of course, the location software, which works as auto-location with a number of methods. Even with a single station. Since 2012, we put in operation in our software, because the methodology was already known by decades, using the 𝗏𝗏𝗃𝗏 method. So using a three-axial seismometers, you can determine the position of an earthquake. You can locate an earthquake using the 𝗏𝗏𝗃𝗏 method. And we can also, using this software, determine the depth using X-ray inversion with ray path inversion of the wave incidenting to the seismic station. But also the software offers grid search, the cycle method, 𝗏71, 𝗏-SEMPTER, 𝗏-ELIPSE, they all well-known methods available from the scientific community. And it's also real-time deconvolution. I mean, when the waveform arrives to the software automatically converts it to the unit you need to determine the magnitude, for example. So convert to Wood-Anderson and convert to filtering to better picking, the PNS, etc. So you don't have to do almost anything. And if properly tuned, the system can determine the location of an earthquake from one station, only one station, one signal, up to all the stations you get for the earthquake. And you can then have the location. In average, in our region, we are located in Perugia, we are here, and we have, fortunately or unfortunately, a lot of earthquakes, hopefully small, and we are continuously testing the system, and we get the notification automatically from the system within maybe 20 seconds, 30 seconds after the earthquake stroke. We have the notification where it is. And then the location can be improved manually by the operator. That's it. It's finished. If you have a question,
Okay, here I will introduce a bit about our bridging experience with Sanlien. And Yes. First, I will go through a little bit about who we are and introduce 𝗘𝗥𝗜 a little bit. And there are two bridges. The first tidal friendship bridge, and another one is 𝗏𝗏 extra dose bridge in Thailand. We 𝗘𝗥𝗜 actually is quite an old company for more than 150 years from Germany, and the red logo. The red logo over here, DSI, would be the most famous logo, as you may know, as 𝗘𝗥𝗜 System International, and we rebranded ourselves from in 2020 with the new CI and red and blue logos here. And if we look at 𝗘𝗥𝗜 with the number, we have more than 15 decades in business with more than 50 countries. That we have more than 10 sector, many specialists, and we more than 100 current projects right now. And most important of all, we partnered with Sanlien since 2021 in Asia region. Okay, we have four main sectors in our company. First of all is the post-engineering and state-capable system, geotechnics and life management, and this is the reason why I'm here, and also the concrete accessories mainly in Europe. Okay. In our two main target in lifestyle management, we will say that it was the IHM and RIM, which means infrastructure health monitoring, and also the repair, inspection, and maintenance. And these are the most two important things in the so-called O&M phase in the infrastructures. And today I will mention more. I will emphasize more in IHM system, and worth mention that in the right part here is the robotic access we use for repair inspection. Okay, and for the 𝗘𝗥𝗜 IHM, our sector of this was located in Manchester in UK, and formerly a Dayton Group. We actually acquired or you can say merged the company from about 2 or 3 or 4 years ago. And this is also the reason why we will cooperate with Sanlien, since it's quite far away, so they cannot support us on the installation or sensors, the part or repair on that. So Sanlien help us on that. And the most and what they help us with is the infrastructure. We call it infrastructure intelligence part. Is we call it II. It's an cloud-based platform with an integrated solution of the sensors. Okay. On a computer. Oh, it's a meeting. Oh, they work. Okay, these are the two bridges, and the left-hand side is the first tidal friendship bridge at the border of the Thailand and Laos. It's quite a long bridge across the Mekong River, and it's a traditional pre-stressed concrete box girder bridge opened in 1994. And the right-hand side is a new bridge and still under construction right now, and we call it 𝗏𝗏 extra dose bridge, also known as the Talana Bridge in Bangkok. It's crossed the 𝗏𝗏 River. It sounds alike, but actually not the same river with the left one. Okay, I'll go from the first tidal friendship bridge first. This is the total view of the bridge. It's quite a long bridge, and you can see the drawings here and the site map. And there are 6 piers and 5 main span in this bridge. And with the approaches, there will be more than 1 kilogram in total. And in this project, we cooperate with the Chulalongkorn University in Thailand. And these are the details. I'll leave it to you. And these are our project sensor outline. We installed strain gauge, 19 strain gauge accelerometer, temperature sensor, deflection, settlement gauge, and also displacement gauge and inclinometer, and CCTVs on that. Okay. These are the drawings and the actual data logger box on site. This actually is from Sanlien. They built this system for us. This is our SHM structure from sensors, data loggers, and some hubs, and they will process the data and send it to our 𝗖𝗯𝗃 cloud platform. And yes, and when it comes to our 𝗖𝗃 platform, I will introduce this. We can have access to this system with any computer or iPhone or iPad with anything you can serve on the internet. And this is actually the 𝗖𝗃 interface of the first type of friendship. You can see the sensor map here, and all the pages and these icons. The others, and this is the sensor map. In this project, we have the comparatively simple hierarchy with only one level and only sensor basis. So there are only seven pages under that. But first, we will come from 3D accelerometers. There are 4 accelerometers we installed on this bridge, and the four representative span on that, and we monitor the natural frequencies of the box girders. So if the natural frequency changes, we will see, we will know that there is something changes. So the further inspection or repair should be applied. And these are the FA335 we applied from Sanlien. You can see that over there as well. And this is the photo we actually shot from the site. And this is the data on our platform. We can see this is the data with a 6 week interval, and we can see the natural frequency. The peak here, this is the mode 1, mode 2. The peak is not moving significantly, so we can say the natural frequency is not changing a lot. So maybe the condition of the box girder is not changing. So this is a good sign for us. And for the strain gauge, we use the vibration wire strain. You could also find that sensor over there. And we applied 19 sensors on that, distributed on the bridges. And the sensor is SG1001, and we have the data back every 5 minutes. When we look at the strain sensors data within a week, this is a week, and these are weekends and these are weekdays. So you can see the more significant waves, bigger waves in the weekdays: Monday, Tuesday, Wednesday, Thursday, Friday. So it's quite clearly that is because the traffic is more intense on that bridge in the weekdays. Okay. And for the temperature gauge, we applied a temperature gauge, one on the outside of the box girder and 7 inside the box girder. Outside box girder, you can see here. This one we applied it in the pier. The temperature sense we use it would be TP100, and we have 8 of them. This is very interesting picture here. You can see this one with more obvious wave is the outside one, which means the air temperature. And you can see the 7 temperature sensor in the box girder is a little bit delayed and with more stable strand. Hey? Okay, then this is the deflection gauge, also called the settlement gauge. We want to see the foundation, the condition of the foundation, see if the settlement occurs or something like that. We have actually a set of that will consist from 31 deflection gauge from we call the liquid level settlement gauge. It's a sensor like this. It's a LP150. This is a little diagram of how it works. It has a water tank, and all these 31 liquid level gouges are connected together, and we could see the relative settlement within the gouges. And this is what we saw that this is in a month. This is in a month. Now we can see this data is up and down within 4 millimeters. This is not a very big value for us, which is also a good sign for us. And since this is not a short-term indicator, we would have to see it with more longer intervals. And this is displacement gouge. We placed 8 displacement gouge on that sensor on the between the pier top and the box girder. As you can see here, these are the pier, and then there's a pier top, and there's a little strain sensor LP200 over here. And as you can see here, we can find, please remember there's a DP04 here. This one is the fixed one. The other one between the pier and the box girder, they are sliding device between them, and this one is kind of a monolithic one, so we will see no displacement over here. As you can find here, the blue straight line here belongs to the fixed ones, and you can see from the left hand side they will go to the negative side, and the other will go this way. You could also see very, very clear patterns within a day, repeat and repeat again. It will mainly from the temperature. Yes, and if we put temperature in, you can see, we can find that when the temperature goes hotter and colder with the bigger waves, the displacement sensor will see this. We'll see the same trend. Yeah. Sorry. And when it comes to tilt meter, we also apply the 6 tilt meter on every pier, and also the tilt 03. This one is on that fixed pier. We will see something interesting later. And we applied this Midori inclinometer on the picture, and the installation is also from Sanlien. And we can see the inclinometer data here in the deep green one here, tilt 03. We'll have the comparatively minor tilt in this data. So we are thinking this might be because that one is the fixed one and with more stiffness on that. And we have also applied two cameras at the end of the bridge, and we have the live stream camera, and also we retrieve a photo per hour. And this is the photos recorded on our system, and I would like to share some interesting. We can see rains and sunset and something like that, and also a train passing by. This is the data acquisition system from Sanlien. These are the actual data box they provide to us. And we're going to Macron extra dose bridge, which also called the Tanara bridge. As you can see here, this is the third bridge over here, lying parallelly, and the bridge we're talking about is the yellow one right here. It's an extra dose bridge. It has 2 pylons, about 250 meter in main span and 340 meter in total. And also the yellow cable here is also provided by us. This is our sensor layout. You can see the sensors we applied here: accelerometers, tilt meters, blah blah blah, and I'll introduce to you later in these pages. We applied 8 accelerometers for the for the cable force, to see the cable force, and one temperature sensor, weather station, with include wind speed, wind direction, and rain gauge, and also the temperature and the relative humidity. And 2 in kilometer on the pylon top, and also 4 CCTV to see all the deck. This is the drawing and the actual photo from the site. And this is our SHN structure from Sanlien as well. It's quite a little bit like the first data bridge, also sensors, data loggers, blah blah blah. And the sensor will somehow process the data and send it to our AI platform. And let's see. Let me jump that over. Okay, this is our actual view of the AI platform. We can see this. We can see the bridges over here, and the sensor we apply. With a click in, we could see the sensor data and the graph of the map. The hierarchy of this. So this is more complicated. With also we have 2 pylon view. It's a pylon section to see the sensors on the pylon. And first accelerometers for cable force. These are the actual photos of that. We applied eight accelerometers on that to monitor the cable force, and the sensor will retrieve the data every 5 minutes. We applied the FA135. This is a typo here. It's 135, and with the data logger DMS24 to. This is the photo. This is the photo just installed on the cable. We use a fixture to fix that on the cable and to see the cable vibration. And this is the kind of a method statement of how we transfer the accelerometer, the acceleration to the cable force. We will transfer the acceleration through FFT or PSD power spectral density, and to fetch a natural frequency of that cable, and then through some simple algorithm we would get the cable force. And then temperature gauge, we apply 2 temperature gauge. One is in the box skirt, and another is integrated in the weather station here. As you can see, this is what we do. We drill a hole and put the temperature gauge in, and another one is here. As you can see here, the air temperature outside is apparently with very big wave, and the sensor inside the box was also a little bit delayed and more smooth. The weather station here, we also have another rain gauge and anemometers on the pylon top, rain gauge on the deck. We apply these 3 things. You can also see there, yeah. It's all, yeah. And we could also have all the data on the platform. We can see the sensor. We can put it together to see if anyone is influencing another one. And this is wind direction and the relative humidity. Yes, here it comes to the strain gauge vibration. Time's up. It's okay. Okay. Let me go very, very quickly. CCTVs, tilt meters, the CCTVs, yes, photos. Yeah, thank you.
Good afternoon. Thank you very much to everyone. Well, first of all, I would like to thank Sanlien for inviting us today from Mexico to come to the other side of the world to present our company and to present what the solutions are for our company. I would like to introduce myself. I'm Jocelyn Vargas. I'm the CEO of 𝗏𝗏𝗏𝗏 in Mexico, and we work also in Latin America. And my colleague Cesar Morquecho, who will be presenting one of the basically examples of what we want to do with Sanlien in the future in terms of integration of the systems. So, All right. I will speak about our company profile and what we do in Mexico. So it's not. Sorry. Can you see the next one? Yeah? Okay. All right. So who we are? We founded the company in 2018, basically after some of the biggest earthquakes in Mexico, with the main mission of providing solutions for prevention in earthquake early warning or instrumentation. So we basically started as consultants, doing some field work and doing some projects for mainly structural health monitoring. After some months, we were approached by 𝗘𝗏. We are representatives currently from 𝗘𝗏 Systems. I will talk about that later. And we started providing services as providers of hardware in the seismic area. Currently, we represent the brand in Mexico, Costa Rica, and Panama, and we are trying to expand from all Latin America. Then, well, our main work currently, as we've developed the company among the last 4 or 5 years, we started seeing that the integration of more services, thinking about communication, doing more work on seismic networks and monitoring, that gave us a platform to start working more on the servicing part. So during the pandemic, we developed this servicing model for our company, and we are currently working towards more on the monitoring side. So we work mainly with the energy sector, geothermal, wind, oil and gas. We work with mining, and we do work with civil engineering. Our main services include the configuration, installation, and maintenance of seismic networks, configuration and installation of telemetry networks as well, provision of seismological and geotechnical hardware, which is basically the reason why we started talking to Sanlien here. We do induced seismicity monitoring, and we do data processing and analysis from there. We do installation of seismic and geotechnical monitoring systems as a company. So some of our commercial partners, as Sanlien, we are representing 𝗘𝗏, which is one of the best well-known companies in the world for seismic hardware. We've been representing them for 4 years already. And we don't only provide the services, but we do after-sales part with this company. From our representation with 𝗘𝗏, most opportunities or more opportunities started opening on other sectors for the same monitoring and integration part. So we started working with this brand, which is 𝗏𝗏𝗏𝗏. 𝗏𝗏𝗏𝗏 is a software as a service provider for monitoring systems, mostly on the structural health monitoring. That is a software as a service, and it can integrate everything from the seismic part, hardware, or geotechnical in just one single platform. The most recent partnership that we got, and this is, well, you will have a presentation right after with Benny Sasson. Benny Sasson is the CEO of Seismic AI in Israel, I'm sorry. And we started this joint venture together in Mexico and Latin America for Seismic AI, for which I am proudly the CEO. Some of the examples of what we've worked with recently, and this is just some of them. We've worked with seismic networks. We do work a lot with the academia. We work with investigation, mostly. Recently, we instrumented one of the most important networks in Mexico City for earthquake alert warning and data analysis and monitoring. So this is one of the pictures of the installation that was done almost a year ago. And it has been a very successful project. From the solution with QuakeLogic, we work with bridges. In this case, we have used any other type of hardware, basically with the company, with QuakeLogic, sorry. And we do the installation, the integration, the instrumentation part, and to put a turnkey solution here. We have worked also on structural health monitoring for a control tower in Mexico with data analysis, not only from the continuous monitoring, but analyzing also the vibration of the structure. And we are also working with dams, also using the same QuakeLogic solution and the hardware from 𝗏𝗏 and any other type of hardware that you can use. So, well, basically, this is the profile of the company. Cesar is going to talk to us about one of the examples of how to integrate all the systems with Sanlien solutions together. Thank you.
Okay, thank you very much. My name is César Morquecho. I am working with bases sísmica. My presentation is about case of studies of the instrumentation with Sanlien for the next months. Our outlines is main objectives for dam monitoring, seismic instrumentation for dam solutions, integration of sensors, different solutions with Sanlien instrumentations, structural health monitoring products, FPA, SCADA, and dam solution. It's very important this point because in the past, only the seismic instrumentation with the Cyclin mini-seed, and now the instrumentation in dams, they need an industrial protocol. It's very important. That is the solution with Sanlien. The Modbus protocol is very important for SCADA and take the decisions. It's a good solution. In this case, is our case of a study. Our objective is after an earthquake event, certain organizations may face stressful challenge, such as using or evacuating structures. But they need take rapid and quick solutions and structural health monitoring quickly. That is the reason because we are working with different instruments, with different solutions and different software. We try solve our customers, but the main problem in Latin America is the communications. Why? Because if you want to use radios, the problem is the repeaters or the vandalism. If you use cellulars, the problem is no coverage. And the solution is satellite, but it's very expensive, okay? That is the reason because we need, we use different solutions with different communications and different solutions. That is very important now, the solution with cables, with Sanliens, with, because it's more easy for us working with these communications. In this case, we use 4 stations. The main station is in the crest. This is the solution typical in dams. We send the data in local radios. Always is a local radios because we can use cellular in some places in Mexico or Latin America. Okay. This one is other solution. We propose the new sensors with communication with cables, but we need to send the data 500 meters or more. This is the case, use radios. Our software use Cyclin, or in this case, QuakeLogic could be use Modbus. It's very important because we can read the data in real time with all these softwares. Okay, that is our goal. real-time status health monitoring notification, action and response plane, facility page for the structural details, and plots, graphs, and analysis. This solution is in real time in our cellular or our web page. For bridge, for dams, the analysis is very important. We have a team for analysis the data in real time, but our software, the QuickLogic and Seismic EA, could be in real time analysis the data. And this is the case. This is our next step and our next project in review the data in real time with SCADA solutions and in SISCOM solution. It's at the same time. The same protocol set the data in the same time. Okay? For dams, instrument benefits, seismic instrumentation currently provide very valuable information which allows to evaluate and support the behavior and or design of the structure. The correct election of instrumentation as well as the seismic and structural analysis made by base seismic engineers will provide our clients with qualified solutions. Thank you very much. Some questions?
Hi everyone. My name is 𝗏𝗏𝗏𝗏𝗏, and I'm the CEO of Seismic AI. As Reed said, unfortunately I couldn't attend the workshop, but I prepared a video that is focused around the technology that we offer, some use cases around the world, and some propositions for potential cooperation in around the world, basically, also in Asia. After the video, I'll be here to answer questions, and there are a few Seismic AI partners also physically there in the audience that we can follow up after the presentation. So thank you for your time, and I'm looking forward to your questions.
Hello everyone, my name is 𝗏𝗏𝗏𝗏𝗏, and I'm the CEO of Seismic AI. First of all, I would like to take this opportunity and thank our hosts for arranging this workshop and for the opportunity of presenting Seismic AI solution for reducing damages from earthquakes and tsunamis. Seismic AI offers an end-to-end service that includes a robust earthquake and tsunami detection, alert, and automated preventive measures triggering. With our breakthrough technologies, enterprises and organizations can minimize the loss of life and physical damages while ensuring a business-as-usual approach before, during, and after a seismic event. Over the last 2 years, our system was successfully tested worldwide. We have collaborated with government or academic seismological agencies in order to test our system in the field, in their territory. In all of these cases, where we installed our network, like Canada, Turkey, Israel, India, the system performance was tested and proven to be effective and successful. So how does it work? At the basis of everything, there is the seismic network. The seismic network may include stations that include a single sensor, the traditional stations that you're probably familiar with, and it may include small aperture array that you can see in the bird's eye circle. The small aperture array is a cluster of 4 sensors that sends the data to a local processing unit. The local processing unit is running our proprietary seismic algorithm that can determine not just the ground movement, but also the speed of the seismic wave and the direction. The output of this processing is sent to the cloud platform. The cloud platform gets the information from all stations and determines what is the earthquake hypocenter, what is the earthquake magnitude, and what is the estimated PGA resulting from that earthquake on each and every of our customer site. If the estimated PGA exceeds a threshold that was agreed with a specific customer, we would send an alert to that customer. That alert would trigger the automated preventive measures that are aimed to reduce the impact of the expected ground shaking. Seismic AI developed 3 algorithms. The first is GSA. It's our implementation of the grid search algorithm. It's an algorithm that is similar to what's used by Epic, for example. The algorithm is using a standard seismic network, meaning a seismic network that is made of a single sensor stations. And this algorithm can transform any standard monitoring system into a real-time earthquake early warning system within minutes, as I'll show you further down this presentation. The second algorithm is MUST. It's a mixed array and single stations. Here, the seismic network is made not just by the single sensor stations, but also by the small aperture array. This is the fastest and most robust solution for alerting against seismic events originating in and outside the seismic network. And the last is VIDA3. It's a virtual dynamic array assembly algorithm. Here we are leveraging standard network, meaning no physical array stations. And the algorithm is building dynamically in real time. During the event, it forms arrays, virtual arrays, and applies array seismology on these virtual arrays. This will gain the benefits of array seismology without deploying physical arrays in the field. Here you can see the GSA algorithm performance in Oklahoma. We have collaborated with Oklahoma Seismological Institute and got a real-time feed from their network of around 90 single sensor stations. And we let the system run out of the box without any customization for 1 month. And these are the results after 1 month. The green stars represent our real-time location, and the white stars mark the catalog location. As you can see, in some places they simply overlap. This is an example of the GSA algorithm performance in Eastern Europe, in Eastern Turkey. After the recent strong earthquake in that region, we have collaborated with Kandilli University and got access to their network of to their seismic network that was deployed in the region. As you can see, the seismic network are marked by the triangles. They are very, very sparse. This is a really sparse network, but still, after 1 month, you can see the results. Again, our real-time location is marked in green. The catalog location is marked in white. They almost overlap. And again, this is just getting feed from their real-time network without any adjustment or optimizations. We've also applied our GSA algorithm on mini-seeds that we got from Sanlien that were recorded during an earthquake in Taiwan. As you can see in the diagram, the network are marked in triangles and the earthquake is marked in the red star. As we start the playback, you can see that the P phase is detected by stations. We get the location very, very fast and also the magnitude. As the event evolves, the magnitude becomes more and more accurate, and also the location, and we also see the intensity circles. This is an example of the MUST algorithm. Here we got mini-seeds during an earthquake from Sara and INGV from their existing network here in central Italy. The catalog epicenter is marked in the black star. The white circle represents an array, small aperture array, and the white triangles represent a single sensor station. I'll let this play. The P wavefront is marked in blue and the S phase is marked in red. Once the P phase is detected by the array, you get a back azimuth marked as the cone. Once the P phase is detected by at least another station, we get a location. And as we get more and more locations, the location of the epicenter becomes more and more accurate. What you see, the black circle around the array, this marks the S-P surface. This allows us to constrain even more the distance to the epicenter, making our location very robust and accurate, as you can see here. This is an example of the VIDA3 algorithm. We took seismograms from the Japanese 𝗔𝗽𝗓 seismic network during an earthquake that happened in 2021 and ran it through our system. Once we start playing, you'll see the P phase detection by the stations, and you will be able to see our initial location and the location changes for the event. Here you have 4 detections. You get a location marked in the red star. You can see it's almost identical to the catalog location. Again, this is out of the box. We didn't put any arrays, physical array or nothing, just tapped into the feed from the existing network. Here I would like to talk a bit about our experiment in testing 𝗏3 algorithm in California. The test was done in the Mendocino triple junction area. This is in Northern California. These are one of the most challenging locations for shake alert or epic. What you see in the diagram is information that was generated by the USGS. The color, each circle represents a seismic event. The color of the circle represents how accurate was it. Green is good, and as it goes through yellow, orange, and red, it becomes less and less accurate to an accuracy miss, like a missed location or a location error of around 100 kilometers. This is the basis or the database of events that we have used. We took information from their same seismic network that they are using. We took the seismograms and we ran them through our system. This is an example of one event that we played, one of the events that you saw before. What you can see here in the red star is the catalog location. You can see the P wave marked in blue. You have 4 triggers by stations on land. And what you can see that the system, the 𝗏 algorithm, chose 3 and formed an array, a virtual array from these through independent or discrete stations. And once you apply array seismology, you can get the 𝗏𝗏𝗃. This is the line shooting from the center of the triangle towards the catalog location. Once you have a direction that you get from the 𝗏𝗏𝗃 that you saw in the slide before, and you have another trigger that is marked by the 4th station that detected the P phase, then you get an initial location that is marked in green. This happens after the 4th detection of the P phase by one of the land stations. As the P phase progresses and moves through the stations, we get more and more P phase detections. What you see here is a P phase detection by another cluster of 3 stations. 𝗏 formed another virtual array from these 3 and calculated the 𝗏𝗏𝗃. What we also see here, marked in the yellow star on the left side, is the epic epicenter at that point in time. And the P phase continue going through the stations, and we get more and more P phase detection, and we're getting more and more virtual array formed in real time. And of course, as we get more and more 𝗏𝗏𝗃 and we get more pickings, the location becomes more accurate, marked here by the red star. The epic epicenter still wasn't updated at this point, and it's located on the left side of the image. This is another virtual array that was formed and another 𝗏𝗏𝗃 added to the calculation. And this is how it looks when the event ends. You have all the S-P circles, you have all the 𝗏𝗏𝗃 that was generated from all the virtual arrays. As you can see, they're all kind of, here is the conjunction of all these surfaces. And you see that our location is very, very close to the catalog location. We're talking about here around 10 kilometers difference, while the epic epicenter is marked in yellow on the left side of the image. This is the result or summary of running all the events that you've seen that were included in the initial test that was done by the USGS. On the left, you have the original, the epic performance. On the right, you have the seismic AI performance. As you can see, we are much more accurate than the epic, and this is out of the box without any tunings, just by taking the raw seismograms from exactly the same seismic networks and running them through our system. Array seismology also allows us to estimate the depth of the hypocenter in real time. For that, we are using a well-known relation between distance and horizontal slowness, as you can see in the diagrams here. Based on a distance and slowness that we get from the arrays in real time, and using this relation, we can estimate what would be the depth or the hypocenter of the earthquake. And if we know that the earthquake is shallow and it is happening at sea, we can issue a probability of a tsunami alert. We don't know how strong it will be, how high the waves would be, or how long it will take it to get to shore, but we will be able to say that there is a probability of a tsunami to occur. This is enough to warn the public to go to a higher ground or take preventive measures. The problem with this relation is that it's less accurate at the edges, where you see all the colors combine into a one narrow strip. So what we're saying is that if the distance is up to 50 kilometers and the earthquake and the magnitude is above 6, for example, we would issue a tsunami alert regardless of what these relations indicates. This is some kind of a safety precaution, just to make sure that we cover also the near shore, really near shore earthquake. To test our real-time depth algorithm, we took several hundred events. Most of them are coming from Japan, and we ran them through our system in order to estimate the depth. On the X, you have the catalog depth. On the Y, you have the calculated depth, which means our seismic AI location. And of course, the closer you are to the one-to-one line, the better you are. As you can see, in most cases where the depth is up to 100 kilometers, our algorithm is very aligned with the one-to-one line, which means that it can be used for calculating the probability of a tsunami based on this. This is a system overview, the seismic AI system overview. What you see on the left represents a customer facility. When we say a facility, we usually mean by energy plant, utility, or infrastructure of that sort. In each one of these facilities, we are putting a cube and a PLR device. The cube is also connected to the facility command and control to issue emergency shutdowns, connect to the ERP, report, and also sound, audio, and visual alerts. It also includes a power backup and communication, of course. The cube is getting the feeds or the alerts from the regional system or the cloud system. The cloud system gets the information also from the seismic network and does the analysis, as you can see in the seismic AI data algorithm box. The alert, in addition to sending the alert to the data logger or the cube, the system can also disseminate the alert to mobile app, SMS or push, email, customized XML protocol, basically any mean of communication that is used by our customers. This is an example, a few examples of screens that we offer our customers and our partner. This is a management and monitoring system. What you see in the center is a view for the command and control center. It shows you overall network activity. On the left, you can get feeds from the health status of each one of the components in the system. On the right, you have a report that is generated automatically for every event that was detected by the system. Using the P-alert sensor that we have in each one of the facility, after the event, we are issuing a post-event report. The post-event report shows what was the PGA that was sustained by the facility, the actual PGA, not the estimate PGA, in the facility, compared to the thresholds that were defined by the customer. This is a valuable information for engineers of that facility in order to estimate what is the risk level of the facility and whether it is safe to resume normal operation, or should they go and look for potential damages in the structure, in the pipes, or in the containers, in storage, or whatever that may be. False alert or misalert has a cost. Performing preventive measures may result in significant loss of revenues, damages to equipment and inventory, and not issuing preventive measures may also have a cost on damages because you didn't protect yourself. The solution we offer to this problem is performance guarantee. Performance guarantee will protect the customers from these losses and increase the trust in Seismic AI solution. Seismic AI will provide performance guarantee in the scope of the cooperation with one of the world-leading reinsurance companies. Performance guarantee will allow short onboarding process of new customers. The customer will get 3 times of the damages incurred up to an agreed cap. In every market Seismic AI operates, we are working with local technology service partner. The technology service partner, or TSP, is responsible for the local marketing, sales, and support of Seismic AI, and also will deploy and maintain the regional network. The TSP may approach the industry or utility customers, or the non-industry. By non-industry, we refer to hospital, malls, hotels, HQ offices, etc. We also, based on the specific market, we also can collaborate with local P&C insurance company. We are not expecting these insurance company to sell Seismic AI services, but we want to use them as marketing channel, because the assumption is, and what is proved, is that using Seismic AI solution will reduce the insurance risk for these insurance companies. So they have a motivation for making sure or driving their customers to use Seismic AI, thus reducing the risk and potentially also reduce the premium. Our technology partner not only selling Seismic AI solutions, but they can also offer professional services to the customers. You have here a few examples of the professional services that can be offered by the technical service provider. And in addition to the professional services, the TSP can also provide consulting services to the customers, starting from risk assessment, integration, impact on the environment, and emergency supply chain planning. I guess this is just a partial list and may change by customer to customer. Thank you all for listening. And again, I would like to thank Sanlien for hosting us.
We want to present to you like a joint project between us, Minotama and Genlogics, for the LRT seismic detection alarm system in the Jabodetabek or Jakarta. So the agenda will be, first off, we will explain a little bit about Indonesian seismic activities. Second one, we'll talk about the LRT projects. The third one will be the origin of demands from the LRT partners for us and for Genlogics as well. And the last one is the LRT project solution that we offer them and that we already installed in the LRT Jabodetabek. So the first one, I want to explain a little bit about Indonesian seismic activities. As you guys know, Indonesia has a lot of seismic activities, one of the most in the world, actually. and it has a lot of earthquakes due to the meeting of major tectonic plates in the region, and highly prone to seismic hazard. Not only earthquakes, but also for landslides, flood, and everything like that. This is the incomplete list of the biggest earthquake in the last 10 years. As you know, the 2004 Sumatran Andaman earthquake is one of the largest earthquake recorded in the 21st century. It also resulted in one of the biggest tsunami in the 21st century, and resulting in more than 200,000 fatalities. Okay, let's start looking at the Jabodetabek LRT projects. Jabodetabek LRT project is supposed to be started at 2019. It has to be finished before the Asian Games, but it was halted due to COVID and other stuff. And also the funding from the government, and also the ownership of the land that they are building the LRT with. So there's a lot of trouble building this LRT. In the middle, so this is some of the details. Phase 1 is 24 kilometers long, and phase 1B will be around 20 kilometers. Okay, we started with the origin of demands. So LRT feels the need to put EEWS or earthquake early warning system in around 2019. First off, OCG founded GenLogix from the websites, and also contacted GenLogix for the EEWS solutions. And then GenLogix contacted Sanlien, and they contacted us, and we forming cooperations to create these LRT solutions. Okay, the next slide, Adikarya is the main contractor, contacted Minotama and GenLogix. So we discussed the contract, and it was done in 2021. It was planned to be finished this year, in May 2023. The project is 70% done for today. The remaining 30% is between the testing and the documentations. Okay, this is the details of the setup of as the usual on-site setup. We used 3 PLED unit, 1 PX01 as the master control unit, 1 unmanaged Ethernet switch, and 1 voice relay module. The sensors has already been installed, and it's currently on 3 out of 3 activations. But yeah, new news just came, and they wanted the 2 out of 3 activation. So if one sensor died, the system will still works. So this is the explanation of the PX01 will have 3 relay triggers, but we only use 2 for high and low. The relay trigger, the corresponding Modbus register will tell the RTU SCADA, and the SCADA will tell signaling, and the signaling will stop the train if the earthquake is bigger than the threshold. So this is the example of the installations. This is the pillar. It's not installed yet. This is the testing period. This is the cage and the fence that we installed in Stasiun Duku Atas in Indonesia. Okay, this is in the underground of the depot of the LRT. This is including the cage and the cabling. Okay, this a little bit bigger, built a little bit bigger to counteract the flood that usually happens in Indonesia, because the flooding is really bad. The last flood reached almost the top of the pier. It's around 60 centimeters from the ground. So this is the LRT setup. This is the PX01 box setup. This is the PX01. We put the switch hub for the cables, and this is the spare cables. We have 2 relays connecting the PX01 to the SCADA RTU, because SCADA RTU only send 110 VDC, and PX01 are under different voltage. This is the configuration. As you guys know, we have three P alerts for the on-site early warning, one switch, one PX01. So we connect the PX01 to the RTU SCADA, and if the low earthquake happens or high earthquake happens, it has two relays that connected to SCADA, and the SCADA will tell the signaling system that whether it was a low earthquake or the high earthquake. This is the power system that we use, the normal power system with the power distribution panel, and also new addition, we'll use also the relay to one relay here connected to SCADA. So if anything happens to the power distribution panel, we could also tell the SCADA RTU that something happens in the power distribution panel. This is the low and high level earthquake. It's the same, basically the same PowerPoints. It's just the different, it comes out from different places. So if the low earthquake will come out on the D1 outlet, and the high earthquake will come out from the D2 relay outlet. Both connected to the relay, and the relay connected to the SCADA RTU, like shown here. So what happened after? Warning and alarm of earthquake at OCC room, at the main control room from the train. And then it will send the signal to power supply to intercept the master echo or the emergency cutoff unit to shut down all of the rail. It will send data to the signaling system, so signaling can apply emergency brake for all trains. So the trains are planned to stop at the next station if there is a high earthquake, but there will be only alarm, number one, if there's a low earthquake. The trigger the public address system at OCC, so the PA system can broadcast to all stations. So number 4 also only happens if there's a big earthquake coming, and so the public sound will sound and tell other people in the stations that there will be a big earthquake coming. Okay, so this is the low and high trigger system. So through the geological survey of the customer to the owner of the projects, we put the 77 on the low on the first relay and 136 gal on the second relay. As you guys know, this is completely configurable, and we only follow the requirement of the customer, because they already have beforehand, they already did the research with their geological team. So this is the result, 77 and 136 gal. And for one other sites, we use 119 and 212. So this is the flow chart of the system of the P-alert and until the RTU SCADA. So we will be triggered by 3 P-alerts, or now 2 P-alert. It will move to the switch, send the data to the PX01 RTU device and MCU device, and the PX01 will tell the RTU SCADA that there are an earthquake, or there will be an earthquake, because this is an early warning system. And the RTU will, as you know earlier, it will send the data to the signaling, and the signaling will do the rest. Okay, the last one is for the troubleshooting. We have, besides the signal that we sent to the RTU SCADA, we also have 3 other functions from this system, which is the WISE unit will also can send a fault signal if anything happens to the 3 sensors or even the PX01. So the fault signal will tell the SCADA that something is wrong with your equipments. The SCADA already have like a monitoring system. That monitoring system will tell you if any of the P-alert is off or if the power is off. And the event of an earthquake, the intensity will also be shown on the monitoring system, the intensity and the PGA, and there's like a light that shows you that the event is happening. The last one is ability to reload the PX01 MCU main control unit. This is also a requirement from the owner. So they can, from the SCADA center, they can reset the PX01 through the control unit, their SCADA control unit. Okay, I think that is all from me. Thank you for the chance to share my experience.
Thank you.
Good afternoon to everybody. So again, my name is Michael. I'm from 𝗘𝗏 company, part of Sanlien's group. And today we're going to talk about solution for rapid climate change and harsh environmental conditions. I would like to take a little step back to the last Sanlien's partners meetings, because actually when 𝗘𝗏 was introduced for the first time, as Jim said, actually we deal with meteorology and hydrology mostly, so probably is not a field that you face in your daily life. So what 𝗘𝗏 does, basically we are an instruments maker since 1925, so almost 100 years of experience in this field. We are not only actually a manufacturer, but we provide the full cycle of products and services connected to our systems. So basically the installation as well as the maintenance of the system. In the case of systems out of Italy, we provide the training on site or remotely to our local partners in order to let them to be autonomous in the installation and all the related services. We focus in all these fields of application, but mainly meteorology and hydrology. Today we're going to talk about climate change. So I'm pretty sure that everyone here knows the topic very well, and what are the causes of the climate change. The global average temperature is increasing day by day, and I think we can all agree that one of the main reason is human activity. So basically, from this graph, you can see two different lines. So two different factors which have influence on the drastic increase of the temperature on the last 150 years. This graph is taken from the IPCC, and you can clearly see that actually the main factor is connected to the human factors. I'm also sure that you know very well about what the effects of the climate change are. We might have an increase in global ice loss of biodiversity, ecosystem collapse, financial and health consequences, as well as many others. But today I'm going to focus on only extreme meteorological and hydrological events. So just few examples, clear examples in our recent history about some extreme events. We don't need to go very back in time. For example, very recently in December 2022 in the US, a huge depression from the Arctic came down, bringing heavy snow and heavy wind. For example, here we are in Buffalo, totally covered by snow. Another event that you may not know is in Italy, Viastorm in 2018. You can see some picture taken from the woods. Actually, at the time, here we are in the Dolomites area, which might be known from some of you. It's quite popular. And in 3 days at the time, we lost like more than 4 square kilometers of wood for the wind speed. Wind speed which reached like between 100 and 200 kilometers per hour, so close to a hurricane, very rare for our areas. And another information, just to give you the bigger picture of this event, was the intensity of the rainfall, as well as the amount of the rainfall at the end of the event, which has reached almost 80 centimeters in only 3 days, with only one river capable to bring all the water downstream. Another two completely different extreme events. The one is California last year. So California was actually affected by 2 completely opposite but strong events in only 1 year, because you know, I'm sure that recently California was totally covered by snow and ice, so two extreme events in only 1 year for California, unfortunately. But it's not only California, not only US, it's also India. Here we are at the opposite side of the world. The drought that occurred in between 2016 and 2018 was one of the heaviest of the last century. Everything is to say that actually the climate change is visible, tangible, so we cannot avoid the consequences, we could just try to mitigate them. And this is 𝗘𝗵𝗂𝗍𝗂's mission. 𝗘𝗵𝗂𝗍𝗂's mission is to collect data from the field in order to try to predict these kind of events when it's possible. When it's not possible, what we can do is to implement early warning and early detection. So this slide is just to give you the bigger picture of how an early warning is implemented and how this kind of system can work. I took the example of a flood, but basically this structure can be applied to any other kind of events. And the concept I would like to convey here is that the system is composed by different elements, and each element has a specific role in the event timeline. So for example, for the flood, we have step 1. We monitor the physical parameters, which are precursor parameters. What does it mean? Actually, parameters which can trigger the event, which can cause the event at the beginning. The step 2 is a continuous monitoring of the triggering parameters. So the parameters which might bring us to detect an alarm, so to implement physically the emergency on site. The third step is divided in 2, is the activation, the proper activation of alarm and emergency. It might be implemented on site, on site by the activation of acoustic or visible alarms, or by remote, from the transmission of the alarm on site to a remote platform. So today I'm going to give you few case studies we have implemented for different kind of events. This one is in Tuscany region, Italy. We have implemented like more than 600 meteorological stations on the territory, connected to a remote data center through UHF radio, which is a standard for Italy for this kind of system. But what we can practically do with this kind of system, because we're talking about monitoring, yes, but the purpose is, on the one hand, to give to the local authority the necessary data to provide weather forecast and definition of different alert codes according to the risk level. On the other hand, we can perform soil defense. Here you can see an example of a typical water level threshold. For example, you can see the yellow line, which is basically the pre-alarm level, and the red line, the proper alarm threshold. And this is the system from the point of view of the technology applied. We have a hydrological station installed in the bridge with a water level sensor, might be ultrasonic or radar technology, whatever the case might be, connected to a data logger, and this data logger is able to activate some kind of alarm devices, if necessary, on site, or even to transmit remotely the data to the platform for the alarm dissemination by remote. The alarm can be disseminated by different methods like SMS, email, or even voice call to different users at a different level as well. This is another early warning and proper early warning system implemented in Italy for debris flow. We are in the Dolomites region. As you can see from the left picture, which is a satellite view of the basin, basically we have a very a huge jump between upstream and downstream. So the altitude, the average altitude of the upper part of the basin is more than 3,000 meters, while the lower part is less than 1 kilometer of altitude. So what's the problem with this basin? Actually, especially in the summer or early autumn, when heavy rainfall occurs in this narrow basin, because we're talking about a very narrow area, the Dolomites rocks, which are compact, are able to convey it and transport rapidly all the water in high energy water currents, and these water currents is able to mobilize a huge quantity of sediments downstream, because the second half of the basin, the lower part I mean, is made of incurrent sediment. So the result is a debris flow which might affect a village which is present at the lower part of the basin. Here you can say the network fixture, the network composition. We have 4 hydrometeorological stations installed upstream for the rainfall measuring, and 4 geotechnical stations installed downstream, directly connected with the traffic lights for the alert of the road and of the population as well. All the stations are connected through a central workstation installed on site through UHF radio, which is the most reliable system during these kind of events. And each station is also backed up with a redundant communication system, which is GSM. This is just 2 pictures to show you the 2 different group of stations actually, because there are 4 stations here. So station 1 is the group of 4 stations installed upstream, and station 2 represents the group of stations installed downstream for the debris flow detection. The station 1 is quite intuitive because we are able to set a pre-alarm state just based on the rain intensity. Well, I want to say a few words on the downstream station. Downstream stations are installed, and the purpose is properly to detect the debris flow once the debris cross the section. We have 3 different stations, and each station is equipped with different extensometers. So it's basically a simple on-off switch, and these stations are connected to the traffic lights and with an acoustic alarm to alert the population. We also have the use of, we also have a couple of geophones. Geophones in the timeline of events are like in the middle, because actually the vibration starts at the very beginning of the event. So we are able to, let me say, set a pre-alarm. This is the scope, but actually the pre-alarm is officially set upon the level of the rainfall. Just a clarification about the name of this system, which is 𝗟𝗓𝗏. 𝗟𝗓𝗏 has been developed jointly by Macros and a center of research, a very famous center of research of Italy. The original name refers to a system which is implemented through the use only of geophones, so no extensometers or other devices. But in our common language, actually in our daily language, we call 𝗟𝗓𝗏 every kind of system that can be implemented for the early warning of debris flow. And this is the system concept, system diagram. I don't want to complicate, actually. I think, I hope it might be, it can be clear enough for you. This represents the upstream station with the regain gauge. This represents the downstream station. Everything is connected. You know, the upstream and downstream, both are connected to the regional radio network through UHF radio and through the internet through FTP transmission. And both radio groups are connected locally with an early warning management system, which is directly connected to the alarms. What I want to convey here that debris flow is a very rapid event with a very low possibilities to be predicted. So it is crucial for this kind of system to be fast in the alarm triggering. And this prompt action is guaranteed by two factors. The one is the use of a radio, because it's the most reliable system. And yeah, basically, yeah, the UHF radio is I think it's clear. I hope it's clear. It's connected through the main station to the other group of station. Okay, this is another case study. This is a completely different case study, actually, because we are talking about tidal monitoring. So it's not an early warning, but the continuous monitoring of the system is functional for the authority to perform a tidal forecast and early warning to the population of Venice. I'm sure many of you may know that Venice has a big problem, which is high water, especially with the strong wind from the south. The tide is increasing, so we might have also 1 meter of water in the middle of the city. So basically we have implemented a system which is composed by 23 weather stations installed on site. And the weather stations are measuring not only the weather parameter, but also the water level. And the transmission system is always UHF radio. This is a graph taken from the authority. So basically, our data collection platform is able to implement automatic data export to the forecast model. And this is the forecast and other dissemination implemented by and published also by the authority. This is a slide to show you the system from the point of view of the technology. So basically, we have a continuous monitoring of the weather parameter through ultrasonic level to different weather sensor, and the monitoring of the water level and the wave main parameters. So basically amplitude and period by an ultrasonic sensor. Everything is connected through UHF radio to the remote data collection platform. And this is the last example of continuous monitoring. In this project actually is not an early warning, but actually we are evaluating with this customer, which is the national authority, the National Wave Authority of Italy. We are evaluating the possibility to implement an early warning for tsunami. We have installed 8 buoys all around Italy, offshore indeed. And the buoy is equipped with different weather sensor as well as probe for water quality and wave sensor. And the transmission system in this case is satellite, because indeed we don't have signal availability on site. We don't neither use radio. So the system is satellite. GPRS system is on board just as a backup in the case the signal is present. So basically, the scope of the system is a monitor, but actually everything is already on site. Everything is already every kind of sensor is already installed, and we might think to implement an early warning system based on the different parameters which are required. On the one hand, we have, of course, the wave amplitude. On the other hand, for sure, we need to trigger the alarm through the wave period, because actually, as you know, the tsunami is a long wave. So the significative height is not enough, because you may have, for example, 1 meter wave, which is quite common in the Mediterranean Sea, but 1 kilometer of period of length of the wave, so a huge period. So you might be not able to identify the tsunami in this case. And this is last slide, just to show you the system from the point of view of the technology. In this case as well, you have a different sensor. The main one is the wave sensor equipped with accelerometer and inclinometer. Everything is connected to the data logger and remotely transmitted by Iridium system. Thank you very much for your attention.
Good afternoon, everyone. I'm Gian. I'm not Ira, by the way. I'm here today to present to you what was written on your ID cards. Okay. Now, before I start explaining to you what our capabilities is, let me first tell you who our company is. We've been in the Philippine market for about 20 years now. We've been supplying total solutions for each and every clients we had, different, unique solutions for them. So meaning, the solution for this client is different from this client. Also, we provide system integration, preventive maintenance and calibration for our clients, decontamination of other equipments, and fabrication and repair. And now let's proceed on what our capabilities are in terms of environmental monitoring. As you can see here, this is our clients in the Philippines, from video thermography, continuous capacity monitoring system, real-time online mobile air quality monitoring system, etc., etc. But let's focus on these three aspects. The real-time online ambient particulate monitoring, the real-time online water quality monitoring system, and the early warning system. First, let's talk about the localized weather forecasting and early warning system. By the way, we've been partners with 𝗘𝗥𝗜 for almost 4 years now. We've been partnered with Michael and his team since 2017. Also, our system is mainly composed of their system together with our equipments from our other partners. Here is a schematic diagram of our system when it comes to localized weather forecasting and early warning system. Let me first tell you the backbone of our system itself. The backbone of our system itself could be subdivided into 3 different categories. Mainly the connection of the measuring instrument itself to the data logger, the data logger to the central management system, then the central management system to our value-added services, which are the web display, the mobile application, and our very own cloud system. Now, for the localized weather forecasting and early warning system, we've used 𝗘𝗵𝗔𝗆 products for this, but we added an extra step further, which is the third part of the backbone I am telling you, which is our value-added services, which we've developed web displays for our clients based on their own preferences. Meaning, if they wanted some of the aspects written down, or they wanted it to be removed, we remove it specifically for them. So basically, we've been doing it for them, for their applications. We've been customizing each and every data for them, so for their own likings. Here is some example of the web browser application we've developed for one of our clients. It's called HydroWatch. Now, one question arises: who is our clients? Who is our clients? Yeah. Basically, Philippines is composed of 1,300 municipalities, and above this 1,300, 300 of them are first-class municipalities. So basically, we've been trying to penetrate these 300 municipalities to have their own localized weather forecasting and early warning systems. Now, let's talk about the online water quality monitoring system. Basically, it has the same backbone as the one I have discussed to you a while ago. But this time, one of our clients have their own management system, meaning we just integrated our management system to their management system. It's just for a redundant backup. They are using their own management system, but the data itself goes through us as well. Here is the example of the Manila Bay Watch that we've developed for that specific client. The specific client I'm talking about here is the regulatory body for our environment monitoring in the Philippines. So basically, they monitor the status of the Manila Bay, the Manila Bay in our country. So we've deployed 5 stations there, telling the total coliform content, the biological oxygen demand, the chemical oxygen demand, the fecal coliform itself for the area. Now let's talk about the retrofitting environmental monitoring instrument with real-time telemetry system. This one is for our air system, air quality monitoring system. Basically, we've supplied a portable air quality monitoring system for almost every mining industries in the country. Now, the regulatory body in the Philippines wanted to have the mining industry to give their data to the regulatory body itself. That's why we are now proposing them to buy a data logger, then do the same backbone, so that the regulatory bodies could record the data from the mining industries. Basically, that's our presentation.
Yeah, my company name is 𝗐𝗏, which is an engineering company related to the EWS-SHM, smart mining, ICT production management system, and the microvibration monitoring system, not Nike's affiliated company. Yeah. We initially started our business with the EWS and the SHM, but now we are expanding our business to ICT solution in the mining sector. So let's start the presentation now. The title is G320 based microvibration monitoring system. The content will be presented in the order of about us, main business, why G320, make a joint business model, and the additional business. 𝗏 was established in November 2017, and 𝗏 has several partnerships with the Sanlien and Italy Sara Instrument. I'm happy to see you again, Mauro, here. And USA Kinemetrics Inc. for the EWS and the SHM business. Also, we have obtained the ISO 9001-1401 certifications. As you can see, the organization consists of R&D center, planning team, engineering team, and the software development team. Here I am as the general manager of the business. 𝗏's main business is the EWS and SHM. From now on, the business item to be introduced is the smart mining and the ICT production management system in the field of mining that 𝗏 pioneered with the 3 years of effort. This system was installed last year at 𝗘𝗁 단양 mine, which is Korea's third largest limestone mining company, and it is in operation very well. It has major functions such as GPS-based location tracking, collision avoidance, production management, and the blasting, vibration, and noise monitoring. Based on GPS, it is possible to check the movement flow of the vehicles in real time, help vehicles to avoid the collisions, and set dangerous areas. Efficiently manage production volume and aggregate production volume by work vehicle and the digging level daily, weekly, and monthly, and so forth, are built to be possible. In addition, it was built by applying the LTE method for stable communication by equipment. This solution is the key solution I want to introduce this time. Since we have been doing business related to EWS and SHM, we can provide a solution that can prevent collapse accident in advance through microvibration monitoring in the field of tunnel mining, location tracking of vehicles and workers, production management, and the microvibration safety diagnosis monitoring system based on mine ICT. In many abandoned mines and limestone areas widely distributed in Korea, ground subsidences are occurring suddenly due to mining sites or natural caves. Before the settlement occurs, large and small collapses frequently occur in the upper part of the utility tunnel in the connection with the groundwater flow. And the microvibration are induced each time. In non-mine, it can be said that mining shafts are always exposed to the risk of falling, and the rock bursts, which are often emerging, can be regarded as a kind of microvibration epicenter and can be monitored. So we designed a microvibration monitoring solution using Sanlien's excellent sensor, the G320. This system can warn of a larger collapse in advance by monitoring cracks caused by blasting vibration, earthquakes, underground water flow act, or microvibration generated from small collapses. The system warnings allows workers to evacuate before a major collapse and reinforce identified vulnerable areas in advance. For this system, high dynamic range sensor having the wide range frequency response, NTP protocol, because time sync is very important between sensors, and the position inversion algorithm are necessary. Why G320? G320 is a new 24-bit velocity sensor designed for vibration application. Its built-in Japan sensors are at the high resolution of 130 dB in dynamic range. It has a wide range of frequency response from 1 Hz to 500 Hz, and can perform time synchronization between sensors through the NTP protocol, making it suitable for performing position inversion algorithm. When using the GPS option, since the GPS must be installed outside the tunnel, NTP is considered suitably because of the disadvantage of requiring a lot of construction such as cabling. When a mechanical force is applied to the medium, it causes the vibration of the medium, the source of the elastic wave. And for convenience, the location is called the epicenter. Feeling the vibration means that particle is moving right there, or that the seismic wave arrives and is transmitted. In general, elastic waves lose high-frequency energy in turn during their propagation. Earthquake, elastic wave as well, generated from distant epicenters are generally observed as low-frequency elastic waves of less than 5 Hz, with the most of high-frequency energy dissipated. On the other hand, seismic waves generated from engineering construction show a relatively high frequency. That is a wide frequency band, approximately 10 Hz to 1000 Hz. As you see in observation of the elastic wave in the frequency band, it needs to build a solution using a sensor with a performance that includes the frequency band of seismic events, falling objects, and the micro vibration frequency band, and the purpose of measuring wavelength can use the arrival time of an event and identify the vibration speed to find the epicenter of the micro vibration through a position inversion algorithm. In order for the position inversion algorithm to be effective, events must be observed from at least 4 locations. Check. Okay, for micro vibration analysis, micro vibration events are monitored and the auto-picking algorithm. And the first break method, page method, and the 𝗖𝗯𝘃 method are used when events occur, and the first arrival travel time of a P wave on micro vibration is used to inverse the input data. XYZ coordinates for each sensor, initial value of elastic wave speed, and the initial value of trigger time are required. And the Rebonberg-Marquardt algorithm is applied to calculate the grade according to the depth of the epicenter. In order to identify the scale of an event, a scale calculation algorithm is applied to classify the risk level by scale. Risk level by depth, size, and frequency is calculated, and after a comprehensive analysis, the level is calculated and an alert message is sent. The main functions are trigger setting, measurement, data processing, and the analysis result reporting. The key here is the risk rating calculation and the 3D visualization. As an example of application, it accurately presents the actual location of the micro vibration epicenter through hodograms and the 3D stereoscopic views and provides highly readable result. As I mentioned earlier, case of micro vibration include the rock burst, fracture behavior, fourth tunnel excavation act, and by identifying the epicenter of such micro vibration, a major collapse accident can be warned in advance. To make a joint business, we can assign tasks. 𝐷𝗏 supplies micro vibration monitoring software. Sanlien can supply G320 stably. A local partner can sell this integrated solution. And also, a local engineering company can deploy communication cables and the power cable and take over the maintenance scale from 𝐷𝗏 and Sanlien. In order to actually create a business, a lot of prior cooperation will be required. Additional business area that we can support include a production management system by RFID solution, hazard gas monitoring system, RF wireless communication system, open pit mine smart mining system. Yeah, 𝐷𝗏 will always innovate and challenge. Thank you.
So let me talk about the earthquake recording instruments in the Philippines. But then a lot of information has been divulged by our colleague from AF Drill. They've been in the business much more than we were. So we're a bit young in the industry. I think we've just been here in the earthquake recording instruments for less than 5 years. But let me talk to you about remote monitoring before COVID. So that's what I was doing. That's me 35 years ago. And we were doing remote monitoring. This is in, let me see. This is in Myanmar. So it had to be a long tube where you will put in the equipment inside. So that was 35 years ago. 35 years ago and 30 pounds ago as well, I guess. So this one is in Saudi Arabia, another set of equipment. I think this is a rain gauge with the size of the solar panel inside. And this was me in Myanmar. The one on this one is the remote monitoring device. Yes. Which one is? Take a wild guess. Yeah, in the middle. I said 35 pounds ago, I guess. So So I was with some German consultants, and the Burmese, my Burmese contact was this guy. So we were just listening to FSK, frequency shift keying sounds, using this monitor. So several projects 35 years ago. So just imagine how things have changed recently. So remote monitoring has been my passion, I would say. And now it's becoming very, very simple with Internet of Things. And how is remote monitoring being done right now with the Cube? So we have the Cube, and this little device is the device which is also being used by Sanlien. It's a device from Lithuania, 𝗘𝗏𝗃𝗏. So we're very, very familiar with that. So we can download the data, you can you can interrogate what's in the Cube. So again, remote monitoring has really gone, it's now very, very simple to do remote monitoring. Let me talk to you about 𝗘𝗏𝗃𝗏. 𝗘𝗏𝗃𝗏, we started in 2005. We were just a simple repair shop. The repair shop, we were fixing UPSs. Not the big UPSs wherein you make lots of money, but then small 500 VA UPSs that you throw away when the warranty expires. So, but then it's just a matter of thinking what to do. When you are hungry, when you don't have anything else to do, you think of ways to make money. 500 VA UPSs, how do you make money out of it? It has to be a marketing play. You have to think about what is missing in the 500 VA UPS. And what is it? You have to make a very, very efficient setup on how to fix the UPSs. So how did we do it? We changed the way repair was being done. So I just hope that you can learn from my very quick experience here, which I'm sure you will be able to use in your businesses. So we became very efficient with our repair. How? When you have an electronics product repaired, what do? You bring your device to the technician. The technician estimates the item, tells you how much it will cost. Then maybe after a few days, come back and say it will cost more because you have to change some more parts. But what we did, we had to think of something unique. We just had two prices for each 500 VA UPS model. Why? It was basically a battery replacement or a packaged repair. What does that mean? My inventory will get crazy because the parts will keep on changing depending on what's missing. But the end user will just be so happy in having just two prices. They know what to expect when the device gets fixed. So for 500 VA UPS that time, maybe it's $100. Change the battery, maybe $20. Change everything else plus the battery, $25. So they know already. So what did that do to us? It became very, very efficient. We can fix so many devices. The clients are just so happy. We were fixing thousands and thousands of units nationwide. So the biggest supermarkets, the biggest food chains became our clients. Next, we came out with a way to resell service. How do you resell service? You resell service since you have two prices per model. Just give them a 20% discount. you can resell the service. So that multiplied my sales team tremendously. So from a small repair shop, what are we doing now? IoT for remote monitoring, my first love. No, well, remote monitoring is my first love. IoT is now new, so it's IoT for remote monitoring. And in the Philippines, where the power consumption is so high, IoT for facilities maintenance and power saving is now very important. Then, because of remote monitoring, we needed to have a way to have a resilient connectivity. Even if your fiber is not doing so well, even if you have a fiber connection, but fiber is only as good as the connection it gets to. So, you get congestion, you get fiber cuts. What do? You should have a way to come up with a resiliency, and that's what we're good at. We can do LTE backup, we can do LTE bonding, we can do LTE satellite bonding, we can do a lot of combinations because you need resilient connectivity in your remote monitoring. Feel free to ask questions. By the way, I'm very, very technical. I was an electronics hobbyist. I was just talking to Chin. He said, "Charlie, you're a businessman. You don't know anything about electronics." No, I was in grade school. I was a technical guy. I still know how to do component level troubleshooting up to now. Anyway, and part of the communication system, sat phones, and seismic accelerographs, definitely, plus the usual UPS cooling and data centers. We're now doing the big data centers and the cooling systems. So let me talk to you about IoT. For those who are not familiar, let me give you a very, very simple overview because not so many people here are electronics engineers. I'd say more people here are civil and structural engineers. So IoT, very simply, things that collect information, things that receive information, and things that do both. Very, very simple. You will not forget that kind of definition. But then what are the business challenges when you are doing remote monitoring? The legacy challenges. It's complex cabling costs. Sometimes the sensor or the cabling and the installation to the cabling is more expensive than the device itself. High operations and maintenance. IT security. Here comes IT saying that you cannot connect to my system because I may be hacked. I may have a virus in my device. So you just don't connect. And sometimes it takes longer to get IT security approval than to have the device installed. Last but not the least, when you have tight SLAs, you just cannot do that with legacy. So let's talk about what we're doing in the Philippines as far as IoT is concerned. We're not using NB-IoT, we're using LoRaWAN. So from these various devices, it goes to think of this as a cell site, or what we call a gateway. And then from there, it goes to the cloud, and then you can have the visualization and analytics. Very simple. And it goes both ways. It's just not one way, it goes both ways. So by the way, this is the weather station that we're using. Let me take a look at your weather station later. So this is an outdoor air quality monitor. This is a sensor for water level. Do you know how big it is? Cigarette pack. 3.5 years life. You just put it there. These are other devices for IoT. I'm going to talk to you about it later. So where can you use IoT for a building? Energy monitoring, all this stuff, security. definitely earthquake recording as well. And these are the more details on what we're using in the Philippines. Oh, by the way, these devices are made in the Philippines. So we are now becoming a manufacturing hub for LoRaWAN IoT devices. So I invested in this company called PocketWorks 4 years ago, and we are now installing a lot. Let's talk about one of the biggest, or if not the biggest, call center in the Philippines with 110,000 employees. So they now have 48 sites. We installed 1,400 temperature sensors. And from there, we just came out with a manual intervention saying, hey guys, you have to maintain the temperature from 23 to 25 degrees Celsius. Manual intervention, not automatic, just reading the temperature, making sure that the temperature is maintained. 10% savings. ₱1 billion a year down to 900 million pesos a year. As soon as we installed all the 1,400 temperature and humidity sensors. And I can do that now in, let's say I need 200 sensors here, I can do that in 2 hours. Because you just have to stick them. Next phase, we will do energy monitoring. Converge is also a huge telecom company in the Philippines. We're now doing remote monitoring. They have 1,800 sites. How did we convince the owner of Converge? We did a proof of concept in 2 days. Now, as we speak, we're installing 300 sites. 2 months, 2-man team, 2 days per site. And another 1,800 sites, 1,000 sites this year. Now, building efficiency, building energy efficiency. So we have a partner, British company, also based in the Philippines. So they did for Dubai, 28.26 savings. And in Dubai Marina, 26.5 savings. In Manila, in the first-class city in Manila, this is what we are doing as far as proof of concept is concerned. We're actually doing the tests right now. But what's interesting, besides air quality and noise pollution, senior citizen tracking, we have not really smartwatches, but just a simple strap, a simple smartwatch-looking device that tracks where the persons with disability are with accelerometer so that we will know if the usual problem, if you are if you are invalid, or even if you're not invalid, if you're old, you slip and fall and die. 2013, I slipped, January. February 2013, I had brain surgery. So that's why I'm quite sensitive to slipping. So I have a smartwatch. I didn't bring my smartwatch, but then my smartwatch always tells me if I slip. But if you have a device that you can strap on your wrist for your elderly that costs less than 750 pesos, that's 375 NT dollars. Is that good enough? I think it is. So we're doing the tests right now in a first-class city in the Philippines. Key takeaways for IoT before I go to ERI. The difference between our company and the big boys like Schneider, like Honeywell, like Johnson Controls, they will always do it big. In our case, we do it very small. Like for Concentrix, we only installed temperature and humidity. Now, they're installing energy monitoring. The next phase is to do, what do you call that? Monitoring of people inside the room. Why? Because when you start correlating all this data, you can get a lot of intelligent data for analysis. So we usually start small. You can get all the analytics, you can reduce waste, and you can decrease that. So these are the key takeaways for IoT. If you want to ask questions on IoT, you can approach me. So let's talk about so this was actually part of my original presentation. It was quite boring. I said I wanted to be a bit more exciting. So what were our experiences on IoT in the Philippines? So to give you a backgrounder, so we have 8,000 casualties, not as bad as in Turkey and Syria. But then we have 20. How many earthquakes does Taiwan have per day? How many? Wow. So not as, yeah, that's worse, huh? So we have 20 earthquakes per day. But what are we doing right now? For 𝗘𝗥𝗜 specifically, so we started 2018. We're starting to do quite well. So I think we will be doing much, much more this year. But then let's talk about the experiences that we had with our installations in the Philippines. The OBO, the Office of the Building Official, for each and every city, for each and every LGU, they have different sets of rules. Even if there is a DPWH, the Department of Public Highways, each and every local government unit interprets it depending on, I don't want to talk about it. So you know why they have to make it very confusing for us. So they always talk about budget constraints. And we have to keep on teaching the end users how to use it, what the benefit is for. And there are a growing number of competitors. But what are our successes? Number one, at first, the clients did not believe on a 3-sensor, 1 data logger configuration. Because the first suppliers were doing 1 sensor, 1 data logger. 1 sensor, 1 data logger. For a high-rise building, you need 3 sensors, 3 data loggers. So the security guard, if there is an earthquake, would run around exercising up and down in order to get the data. So some of the local government units finally agreed it has to be a single data logger. But still, other clients or other building officials will insist on the old technology. Remote monitoring, we always say, again, remote monitoring is key. When there is an earthquake of level 6, magnitude 6 and higher, we are supposed to send the data to the building official. So what did the suppliers do? They have to go to each and every site, download the data, print it, and send it to the building official. Last time we did it, we had to submit a 500-page printout. I doubt whether they read it, but you have to submit it. So now, we just download it, email to them. So they're very happy with the remote monitoring capability that we have right now. And we always make sure that our after sales is reliable. We started fixing UPSs, 500 VA UPS. I think we now have the expertise to make it more reliable. And they believe in us. So we now have lots of clients. The LGUs, they are still a bit difficult to deal with, but we're starting to deal with them. I like the partnership with Sanlien. Really, you are a great, great supplier. There are suppliers that just talk to me and ask me for forecasts. You guys, or maybe I'm selling much more. But you guys support us very well. Thank you for that. Let's give a big clap to Sanlien, huh? But then what I like is the increasing interest in RSHD. So we have to keep on pushing. Us Filipinos here, we have, how many companies do we have here represented in the Philippines? 5 or 4? So let's see what we can do together, because I think RSHD is the game changer. So we have to put our heads together and see what we can do. So, again, my wish list, enhance ERI with RSHD and SANDAS, maybe more. We have to maybe strategize on how to do it better. Strengthen partnership like this. I like the sexy solution. What's this? The 𝗐𝗏𝗏. What's that? Yeah, I like it. Let's see how we can push it in the Philippines. I hope we can do local calibration. And then, what I really love is for us to collaborate with the other suppliers in order to get a nationwide read on what's happening in the Philippines, because we have a lot of scattered data. And towards the future, again, I want us to consolidate the real-time seismic readings. And I want to find partners here to further our business in the Philippines. So with that, guys, thank you. Do you have any questions?
And I'm very glad to presentation our vibration sensor and velocity sensor, especially for the cloud. And here I will do the first introduce for the wireless data transmission technology first. And for the wireless data transmission, this is our outline. And you can see, first of all, I will introduce the NB-IoT, wireless transmission technology. And second, Sanlien's character, NB-IoT data logger, because we embed the NB-IoT technology inside our product. And later on, I will introduce the cloud, some features in the real case. Okay, NB-IoT transmit technology. What is NB-IoT? This is the very features like NB-IoT is called a nano band, an Internet of Things. And we're using a 4G or 5G base station. The station is from like a tele company, so-called sales site, or a station. And this kind of nano band, the servers nearly 100 telecommunication operation in the world already, and it's very cheap. Reduce the cost and maintenance of gateway deployment, because you don't need to deployment you can just use a simple SIM card inside the product and do the wireless transmission technology. And always, all the time, 24 hours operation, the high security, with high security. You don't worry about anyone can hurry inside it. And the transmission rate is 48 to the 150 kbits, relatively faster than ROLA. And most importantly is low consumption. It's only, and low cost. So you just need about $1 per month. This is the very good one. So this data sheet, you can see in the world, they have 13 species and 14 operational frequency band in the world. For example, in Taiwan, we are using the band 8 and the band 28, the frequency domain. Yeah. So for this map, in the color, yeah, this is the already using, currently using the MB narrowband IoT technology in this world. So you can see this is less people, and this is Africa. So most of the place you can see already using the MB IoT technology. So next is I want to introduce our product. Yeah. I believe you already see our product in the place because our Director Leon, he can introduce for you later on if you see my presentation. If you're still interested, you can go there. And 3 years ago, we start to have the first one channel vibration wire dot series. And later on, we have 4 channels. Yeah. And next year to the 2021, we have 1 channel for the VB dot. Yeah, this is for the resistance type. Yeah, I will introduce this later. And to the 2022, we started a remote sitting device. This is very great for do the remote. You don't need to go the field to do the change the setting. You can just, if you have internet, you just change the setting, the data receiving frequency from the other side. And this year, we will have the tiered dot, wireless tiered dot, and the A dot for, this is for the boat and the current type product. And now we already sold out to the Singapore, Thailand, Hong Kong, and the United Arab Emirates, USA, Swiss, and New Zealand. Okay. VW dot, yeah, this is a vibration wire data logger. Then embed a narrowband IoT transmission capabilities. And this technology includes measuring vibrating wire and thermistor signal. Yeah, you can see this is our device. And for here, you can connect to the shoot for sensor. For example, this is for piezometer for measurement depth, water depth. This is 1 channel, this is 2 channel. 4 channels. This is a detailed specification. If you want to know, you can have my PowerPoint. You can see by yourself. And this one is 1 channel. This one, the right one is 4 channels. Okay, next is called a VB dot. And VB dot is data lower than VB, yeah, bridge. This means a wire bridge, yeah, data logger. And utilize the same MB-IoT technology. And the algorithm, the physical algorithm, use the resistive, called a full bridge circular strain gauge sensor. Yeah. And this, if you use a load cell, simple to say, if you use the load cell, you can use the VB dot. And this is the specification. Okay. Next, this is tiered dot. And tiered dot is not hard to understand. You can imagine that they embed electronic inclinometer, a mass sensor inside, and providing a dual axis angle and a temperature measurement capabilities. Yeah, and you can see that you don't need to have an outside sensor here because this is already a all-in-one inside. So this is specification. Yeah. To summarize the phase list for the dot series, we're using the MB-IoT transmission technology to reduce the signal wiring and maintenance costs, and the automatic data recovery function for up to 20 minutes in data compensation, which means that we can get the latest 20 data if the data lost, and connect again. And modify the measurement frequency and the data saving location from the cloud, because I will introduce the dark cloud later. And no need to build a gateway. And this is a very good character, because normally if you many device, you might need a gateway station, but now we put every SIM card, NB-LD SIM card inside, so you can saving the equipment and the maintenance costs. Low consumption provide over 1 year of operation power. Yeah, you don't need to change the battery frequently. Yeah, you put one battery inside, and then the time will be 1 year duration time. And simple configuration can enable the cloud-based automatic monitoring and morning notification. Yeah. And the protocol is MQTT that allow the customer to easy developing the software. Yeah. So this is four the most important character I put here. So if you're talking about a landslide monitoring solution, yeah, for this image you can see for the landslide in the geological name we call the mass movement. Yeah, this is like a lander. Then you can see this is for the inclinator, and this is rain data for gather the rain signal, and A data for the displacement. And VW series, you can measure the depth, underground water depth, and VB for the load sail for the landslide force. Yeah, and 1 channel and 4 channels, the total solution. If you're interested, you can go to our poster place. We will do you can see the real product. And for this slide, you can see the system structure. Yeah, for VW dot can connect to the sensor for piezometer and crack meter, and for the VB you can connect to the load cell. Yeah, of course, VW also can connect to the landslide gauge. Yeah, from field part, we do the NB-IoT, then we quickly the signal go to the teller station. Yeah. Then here we can divide 2 places. One is the Sanlien cloud, which is mean you want to use our the cloud made by Sanlien. Yeah. Then after that, we have 3 kind of data gathering, like internet to see the real-time information on your laptop, your computer. And if you want the data, you can see the data through the FTP protocol. Then if you want to retrieve some only you want interesting, you can ask your software engineer to pick out some of the information through the API service. Yeah. And if you want to use the Sanlien's cloud, you can use your privacy cloud. We can provide the information, and you can build your own cloud and do you think for yourself the website or the client the information service. Okay, next I introduce the cloud service from Sanlien. For our cloud, the main service, we have calculation the function for the physical quantities. That means when you gather the value, is only a value, but in our cloud we can give the formula inside then the value will change the meaning for physical quantities. Yeah, and the data is real-time monitored and display. You can see here. This is like this is one of the case our cloud map here, and we has the historical data included download. We also include the curve, yeah, like a line. And we have the safety value setting function and the display of safety status by the red, yellow, or green here, you can see. Then the display instrument installation location, a real-time monitor result, and the safety result light on the map, like here. Yeah. Of course, FTP protocol transfer the data. And we also can give you the SMS message via the email or cell phone. And also we can give you the notification if you the email or the SMS when exceeding the message value. This year we add some new function for our data cloud. For example, this is change the frequency, the data gathering frequency. For example, when you set on 1 minute to get the data, if you want to change to the 5 minutes, 5 information per 1 information per second, per minute change to per 5 minutes. You can put it here and drag the list, change the value, the frequency value here. And this is so-called, I say previously, you can change and remote to the on-site and change the setting. And this is a new function. Okay, second one, the new add function is we added the offset of the quantity calculation, the physical quantity calculation. And this is a formula, and sometimes you need add an offset value you can put here and change the value. Okay, and also we can add an email sender message setting. Yeah, so the information will it will give you information through the email. And then the other one, you can add the customer account. Like if you have a client to use our cloud, and you don't want to, you want to control your client the information, you can add your client information here to give him the information. Yeah. Okay. Here is 4 real cases I can show you guys. Okay, this is one place in north of Taiwan, Raifang. Yeah, and in the real case, you put a pulsometer and a load cell. Of course, the pulsometer is embedded in a VW dot. Load is put in the VB. So this is a photo, real case photo. Yeah, the red one is a pulsometer. It's a hole into the ground to measure the water, the underground water. And this is a VB dot. And you can see here, the yellow one is a load cell put on the anchor of the slope. Okay, the second one is last year we have a serious landslide occurs on the event occurs on the Highway 3, number 3. Yeah, in that time, newspaper always report this, and we put the pulsometer and the load cell again here. Yeah, this is a real case. Yeah, anchor here, and this is a pulsometer hole. Yeah. To real-time monitoring the landslide. And case 3, this is in the middle part of Taiwan. And this is the groundwater level an investigation after completion of the geological survey drilling and put a Paladio and a 𝗏𝗏 dot in this place. It's nearby Taiwan Strait, is the ocean, offshore. Okay, this is a time series, and if you zoom in to see the line, and this is a so-called daily vibration curve of underground level influenced by tidal inflation. Yeah, and in this time, you can see a local big rainfall occurred, and the piezometer measure the quick rise of the water level. Yeah, very easy to see in this place. And the location is put nearby the ocean because they are worried about consider maybe some water will affect the area. Yeah, and 𝗘𝗁, you can see this is a factory. We monitor the concrete tank loading. Yeah, so we use a string gauge add we embedded to 𝗏𝗏.4. Yeah. So this is a string gauge made by Sanlien, and this is a line, and that's we put it on the leg of the tank, concrete leg, 4 legs. Then of course we use one 𝗏𝗏 dot with 4 channels, and each legs we put one channels in here. Yeah, and this, about all they are vibration series. Yeah, and later this is I want to introduce a product called the G320. And if you are already familiar with our product naming from Chen's introduction, and you will know the G is mean the velocity sensor, and 3 channels with 120 decibel of the dynamic range. Yeah, this because this is a velocity sensor, so I put the introduction from this slide. Yeah, and especially introduction the cloud service. Okay. On the computer. No. 好像到底了，是不是？哦，好，谢谢。Yeah, sorry about that. Yeah. 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 Okay. Yeah. Okay, this is a velocity sensor, and for the do you know what is G mean? No, it's okay. Yeah. So because why I put here, because this is a velocity, and the velocity sensor always used for the civil engineering part, and this introduction I gather the cloud service, so I put here. Yeah, so allow me a little time to introduce for you guys. Yeah. For the G320, yeah, the velocity sensor creating the G320 field background dispersion, and if you put it on the cloud, is easy to management. And for the velocity sensor, we have the thin algorithm and a daily real-time daily so-called 𝗶𝗶𝗵 storage information, and it can easy to download and quick to get the real-time information, and also physical data checking. Yeah, I have only 3 minutes, so it's okay. Really slow slide here. So this is a topology. If you have many velocity sensor here, then you can quickly put on the internet and through the put on the cloud. yeah, the cloud, we have the service, the website here. Yeah. Okay, this is very easy to setting if you put every sensor, the serial number here and put on the cloud, and you are quickly to get some information somehow like here. Yeah, you can ask your client to have a username and password. I mean, you can give me the username and password, and when you click the enable the function, and it will quickly to log in this. Yeah. And this is the real information inside the web cloud. For example, this is you want to download the CSV file, which is mean the event file. You can click here, and the information will download to your local laptop. Yeah. And also, we can put the information in your cell phone. And this is in Taiwan, we are very popular use the line notify. So the first DIN report will you will see the information on your cell phone. Yeah, we can do this kind of service. Yeah, thank you. Yeah.
And in this last session, we will showcase our two powerful products. They are 𝗓𝗏s and 𝗏𝗍s. You may have heard of them yesterday, but I am confident that you will fully understand them today. And let's begin by introducing 𝗓𝗏s. 𝗓𝗏s stands for Sanlien Data Acquisition System. This program aims to integrate all the features needed to use our vibration product in 𝗓𝗏s. We aspire for 𝗓𝗏s to become the top data acquisition system program in the field of vibration signal on a global scale. And the main developer of this software is my colleague Johnny Young. Yeah, you may have seen here the handsome man sitting behind him. And I will now introduce 𝗓𝗏s from a user's perspective. And by the way, this is 𝗓𝗏s icon designed by Johnny. Yeah, she's both a software engineer and an artist. And 𝗓𝗏s has a variety of functions, including first, we can use 𝗓𝗏s to configure Sanlien vibration instrument. And we can, in 𝗓𝗏s, we support up to 108 channels of data streaming simultaneously. Third, 𝗓𝗏s also offer continuous data recording and analyzing vibration data. We have a lot of digital signal processing algorithm in this software, and also the vibration standard and seismic scale you can use. And final, 𝗓𝗏s can automatically generate reports based on the analyzed data. And these features make 𝗓𝗏s as a comprehensive and powerful monitoring system for a wide range of applications, including but not limited to industrial monitoring, structural health monitoring, and environmental monitoring. For instrument setting, if you have an attempt to modify our instrument configuration file, it's likely that you download the file through FTP. After making necessary changes to the parameters, you will then upload the modified file and restart the instrument. However, now this task can be accomplished through 𝗓𝗏s. 𝗓𝗏s offer a user-friendly set of features, including a program editor that comes with parameter hints and automatically error checking. These built-in tools help us to reduce the likelihood of errors occurring during editing the file. And SANDAS supports up to 108 channels, which is shown in this video, and can continuous recording. It's can do a continuous data recording, and making it efficient and effective monitoring system for various types of data. In addition to supporting various types of data monitoring, SANDAS also provides a special monitoring interface. Yeah, it's for our seismic switch, SS300. Yeah, this interface allows us to visualize the current state of the sensor in a dashboard, making it easier to identify any potential issue or anomalies. With this feature, user can take proactive measures to prevent any damage or failures that may occur due to seismic activity. And SANDAS offers a variety of analyzing tools, including digital signal processing algorithm and global vibration standard. You can see we have the German vibration standard thing, and also ICE for blast, yeah, for blast monitoring, yeah, and ISO, also some seismic scale, and our RSHD, the rapid structural health diagnosis. Yeah. By utilizing the vibration standard function, SANDAS is capable of generating reports automatically, saving users valuable time and effort. Additionally, we are always happy to develop functions and features to meet the specific needs of our customers. So if you have any particular requirements or requests, please do not hesitate to let us know and to let Johnny know. Yeah, and we will do our best to provide our customized solution. And this example of ISO 2631 report. And through this report, people can understand the background noise when it is perceived by residents or passengers. This sample data shows the result with 0.0051, which is under a perception limitation, 0.015. It means people will not feel uncomfortable during this time in a train or building. SANDAS can automatically generate this report, yeah, making it easy for users to analyze the data. And I am pleased to announce that we will be conducting a training course on March 29th to 30th. In this course, you will have the chance to practice using SANDAS and HASAS algorithm on your own. And don't miss out this great opportunity. And okay, let's move on next topic. And there are approximately 500,000 earthquakes occurring globally each year. And basically in places where there is a tectonic movement, earthquakes may occur. And the map in the upper left is a global earthquake occurrence distribution from 1900s to 2013, as compiled by the USGS, and USGS stands for United States Geological Survey. The following table lists some earthquakes that have caused serious casualty. While thinking of these occurrences, we should also be vigilant and think about how to reduce damage. Is there something we can do to mitigate the earthquake effects? I believe we will find the answer in this presentation. And now imagine that a catastrophic earthquake is happening. And fortunately, the building you are staying in has not collapsed in the first moment. So what would you do? During the earthquake, you may and install standards, and using our eyes 3D algorithm. During earthquake, you may drop down under a heavy furniture, such as a table or desk or your bed, and cover your hands to prevent being hit by objects falling down. And hold on to the objects you are under, so you can remain in cover. And after main shock, you may evacuate to the outside of the house. Observe for a while to check if the structure is safe or not safe. Then you might choose to take a chance to go back to your home, maybe to get your personal valuable things, or to get someone's valuable thing. And however, this decision may be fatal. We can use Japan Kumamoto earthquake as an example. In 2016, 2016. Most of buildings collapsed during the aftershock instead of the main shock. Many people were buried in a rubble of the building. So sad. The main and drop down. And where are we? The main reason was that they came back to their home without checking the structural condition with a structural engineer. But in this situation, But in this situation, we found that the structural engineer, I need to check my time. 15 minutes. But in this situation, we find that the structural engineer was short-handed. Hundreds and thousands of building health conditions are waiting to check. And as I know, Japan has sent around 5,000 structural engineers to Kumamoto, but it still took them 19 days to finish an analysis report of the building. So how can we shorten the analyzing time to support structural engineer have a more efficient way to do the building check? Can I have extra time, or I need to end? Okay, thank you. And before we move on, I would like to talk about what pushover analysis is. It can help us understand more about what we will discuss later. Pushover analysis was carried out for the best fixed structural building model. To extend the yield displacement and succeeding elastic behavior corresponding to different force applied. We can look at the picture. The horizontal axis illustrates the structural displacement, and the vertical axis illustrates the force being applied. Then you can see while the force is gradually increased, the structural displacement also increased until it collapsed. We can then define the different damage state in this curve. And we can have a valuable information through this analysis. What What if we use this method on thousands of building model, yeah, and then we do the analysis. We can have a reference of what kind of structural behavior will happen to our buildings under different earthquake faults for different structural dismemberment. The pushover analysis is illustrated in this video. Yeah, I believe this video will help you understand. In this video, a 44-story reinforced concrete building was applied a gradually increased lateral force. While the force keeps increasing, more and more structural components, such as reinforced beam and column, get cracked. In the plastic region, the building does not come back to its original state when the stress vanishes. A permanent deformation can be observed. If you look at the picture at left, the curve ends at the 0.031 roof drift and 24 unite force. And even though you remove the force applied, it will have 0.031 drift ratio remaining. The next, when you apply an increased force, the behavior path will be represented in the blue line. It's easier to reach 0.036 drift ratio. It's important to know that when you remove the force from an already damaged structure, it cannot revert to its original state. Then how do we know what's the current state of our building? Yeah, the SHN, Structural Health Monitoring Technique, will come in handy in this situation. Yeah. During the past decades, many structural health monitoring methods have been developed in order to implement an demigitation strategy for civil and mechanical engineering infrastructure. Structural health monitoring techniques help us to identify the structural properties changing by aging or natural catastrophe. Firstly, we install many sensors in and around the building. Secondly, in the event of the structural of a natural disaster, the sensor will collect the data, and after that we do an analysis. Thirdly, we use this analysis report to inform the clients of the safety state of the building. And however, it's hard to define the damage state from the change of maybe natural frequency of stiffness. And therefore, the average inter-story drift ratio developed from pushover analysis, as I will mention. Using the modeling and acceptance criteria published by the Federal Emergency Management Agency, the FEMA, was introduced as a reference. And why do we use inter-story drift ratio instead of the displacement as our index? It is because buildings with different heights that undergo the same displacement will lead to different damage outcomes. And look at the picture bottom left. There are two buildings undergoing the same displacement. One is Taipei 101. The other one is maybe someone's house. Then we will have, and what will happen to them after undergoing 5 centimeter displacement? The result is clear. For Taipei 101, at the height of 508 meters, it has a 5 centimeter displacement. It's common occurrence for Taipei 101. Even the wind can cause that displacement. For a small reinforced concrete building, it will lead to permanent damage. That's why we use inter-story drift ratio as our index. We normalize the displacement by dividing it with the building height. Looking at the picture at the bottom right, I can show you how we calculate the average inter-story drift ratio. The average inter-story drift ratio is calculated by dividing the roof displacement. Roof displacement is shown here with the building height. And after we got the inter-story drift ratio of the earthquake event, we can then look at the table to find what damage state is of our building. And in this page, you can see the full table. The table describes the demand state of different buildings under different inter-story drift ratio. I want to discuss the table in more detail. The first column of this table displays the building types. W stands for wood structure, S stands for steel structure, and C stands for reinforced concrete, and PC here stands for precast structure, and IM stands for masonry structure. Yeah. And if you look at the upper right corner of the table, there are 4 damage states defined. There are slight, moderate, extensive, and complete damage according to different inter-story drift ratio. Yeah. There are 4 building codes: high code, moderate code, low code, and pre-code. They represent building protocol of different type. The most recent buildings are referred to as high code, and older buildings are referred to as pre-code. Yeah. Building construct with high code has more resistance to earthquake event. So you can see that the value are higher than the number below. If the building is higher than 156 feet, all the index should be divided by 2. And it is possible to collaborate with local structural engineer to establish the parameters. During disasters, data and calculation results can also be provided to structural engineer to facilitate the assessment of the condition of house. For sensor installation, we recommend 2 plans. In this first plan, we install sensors every floor of the building, and this can help us know exactly where the damage is located. This is because when we calculate the inter-story drift ratio for every floor, if any of it exceeds the damage criteria, we will know that the floor is possibly damaged. In the second plan, we install sensors at first floor, second floor, and top floor. Why do we install sensors at these 3 floors in the economic package? This is because the maximum inter-story drift ratio usually happens between first floor and second floor. From top of the sensor, we can also capture the whole building behavior. Yeah, and if you need more information, please contact to our sales. And this is the flow chart of our algorithm to the integration process. I think I don't have time to talk it now. And if you are interested, we can discuss after the meeting, or you can send email to me. The main reason we use this algorithm is if we would just do the integrate from our data, we may get the result which is not matched to the real state. Yeah, we may have a drift here. We also verify our algorithm with the shrinking tempo test. Yeah, and we need to finish this soon. Yeah, and the result is very clear. Yeah, this is a experimental model, the full-scale experimental model. We both install the accelerometer and displacement sensor, LVDT, and we can compare both data to check if we are correct down the integration. Yeah, and the integration results and the LVD data are nearly matched with the error rate of less than 10%. And this is how we choose. Why do we choose our hazards? Yeah, you may take a picture. Yeah, because I don't have time to elaborate it. Yeah, because the most important is, well, usually we can finish the calculation within 1 minute after the earthquake hitting. So you may know if you can go back home or not. And we also apply our hazards algorithm to more than 20 buildings. Yeah, including the some company's headquarters in Taiwan. Yeah, and yeah, last is before we end. We hope this lecture can help you gain a better understanding of the pitch. It's still 29. A better understand. I can finish it on time. Yeah, understand of the principle and importance of hazards. While we do not wish for the earthquake to occur, they are difficult to avoid. And hazards algorithm can help us to reduce the damage caused by earthquake. Yeah. And thank you. Any question?